Hello and welcome to the Snoozy Scientist. I'm really glad you found your way here tonight. Maybe you're lying down already. Lights low, the day's last noise drifting away. Maybe you're wrapped in your favorite blanket or sitting in that quiet corner you love, where the world feels gentle for a while. Wherever you are, I've made this little pocket of the night just for you, a calm space where wonder and stillness can sit side by side. Tonight, we're going to wander slowly, thoughtfully, into one of the strangest questions the universe has ever whispered. What could be hiding beyond a black hole? Not in a rush, not in a dusty textbook way, but as two curious minds stargazing together, letting the darkness pull our thoughts further and further out. I should probably tell you now, I've done my best to make this story as sleepy and soothing as possible, but well, black holes are just too fascinating sometimes. So if your mind drifts wide awake with curiosity, that's okay. It'll settle again soon enough, a little wiser and a little more amazed. If you're already enjoying this quiet moment, I'd love it if you gave this story a gentle like. Maybe even subscribe if you'd like more sleepy science dreams like this. And if you're listening from somewhere special, a city balcony, a tiny town, or your favorite cozy chair, tell me in the comments. I love seeing our little bedtime map light up, one dreamer at a time. Just remember, this video, like all the others here, is for relaxation and curiosity only. It's not a replacement for sleep help or medical advice, just a safe place to let your thoughts float. So now, take a slow breath, let your shoulders drop, look up, if only in your mind, and let's drift together, softly, curiously, safely, toward the quiet secrets hiding beyond a black hole. When you look up at the night sky, you see countless stars, each burning with its own ancient light. But hidden among them are places where the story of a star's life takes a turn so strange that even light itself can't find its way out. These are black holes, not objects you can hold, but regions where gravity becomes so strong it swallows everything that crosses too close. To understand how they come to be, picture a star, far bigger than our sun, living out its life in the usual way. Deep in its heart, nuclear fusion pushes outward while gravity pulls inward. These two forces balance each other perfectly for millions, sometimes billions of years. But nothing lasts forever. When the star's fuel is gone, that delicate balance breaks. There is no more pressure to hold gravity back, and so the star collapses under its own weight. The outer layers may explode in a brilliant supernova, bright enough to outshine entire galaxies for a brief moment. But the real secret is hidden inside, in the core. There, the matter keeps falling inward, pressed tighter than our minds can really picture. Imagine packing a mountain into the size of a marble. Now imagine doing that with something many times the mass of our sun. There's no force left strong enough to stop it. In this collapse, the core becomes so dense, so heavy, that it curves the very fabric of space around it. Gravity grows so intense that even light, the fastest traveler in the universe, cannot escape its pull. This is what makes a black hole black. It's not a hole in the way you dig a hole in the ground. It's more like a place in the universe where the rules of motion and light come to a stop. Surrounding this hidden core is something called the event horizon. Think of it as an invisible boundary, the edge where the escape becomes impossible. Once something crosses that line, it won't come back. Not a spaceship, not a planet, not even a beam of light. From far away, the black hole looks like darkness surrounded by whatever is falling in. You can't see the core itself, only the shadows it leaves behind. It might sound frightening, but black holes don't chase things down. They don't hunt, they simply wait. If our sun were suddenly replaced with a black hole of the same mass, Earth would keep orbiting as usual. Our days would be dark and cold, but we wouldn't be sucked in. The same gravity that once held the planets would keep holding them, only now no light would escape to warm our sky. The heart of the black hole, the singularity, is where our understanding falters. Physicists describe it as a point of infinite density, a place where the usual rules of space and time break apart. No one knows exactly what's there, because once anything crosses the event horizon, it's gone from view. We can't peek inside. We can only measure the effects on what surrounds it. Sometimes material spirals around a black hole before falling in, forming a bright disk that heats up and glows fiercely. That glow is how we detect black holes at all, by what they do to their neighbors, by the way they bend light around them, by how they tug on stars nearby. We see the footprints, but never the traveler. Black holes come in all sizes. Some are just a few times heavier than our sun, the remains of single massive stars. Others are millions or billions of times heavier, giants that sit at the centers of galaxies, shaping the stars around them for eons. And while they may seem like endings, they're part of the same cosmic cycle that births stars and worlds. A black hole is what happens when a star's story doesn't simply fade, but folds inward, hiding its light behind a curtain of gravity. So the next time you look up and see that soft darkness between the stars, remember hidden there might be these strange, quiet places where time itself falls inward and light gives up its escape. We don't fully know what waits inside or what might lie beyond, but tonight, that's the wonder we're drifting toward, together. If a black hole is a place where gravity grows so strong that even light cannot escape, then the event horizon is its silent gate. It's not a wall you can touch. It has no surface, no color, no glow, but it marks the invisible boundary that separates what can return from what is lost forever. Imagine standing far away from a black hole. To you, it might look like a shadow ringed with glowing matter, gas and dust swirling around the edge, heating up as they fall inward. If you could hover safely above all that motion, you'd see the event horizon as the outer edge of darkness, the final line before the universe closes its door. Scientists describe the event horizon as the point of no return. This is not just a poetic phrase. It means that once anything crosses this line, a star, a rock, a piece of light, there is no path back to the outside world. The pull of gravity inside is so absolute that every possible path curves inward. There is no direction that leads out. It's strange to think that the universe can have a boundary like this. You can't see it up close, but its effects are real. If you were to watch an object fall toward the event horizon, from far away it would appear to slow down as it approached the edge. The closer it gets, the more its light is stretched to longer and longer wavelengths, becoming redder and fainter until it fades away completely. In your eyes, that falling object never quite crosses the line. It hovers at the edge, frozen in time. But to the object itself, there is no pause. If you could somehow be that traveler, you wouldn't feel the moment you cross the event horizon. You would drift past it without any sudden sign. There would be no signpost saying, "Here is the cosmic gate." One moment you'd be on the outside, the next you'd be inside, your path bending only inward. Time and space change their roles here. Space becomes so curved that all roads lead to the singularity, the hidden heart of the black hole. This is where the idea of the event horizon becomes so fascinating and so mysterious. It acts like a one-way mirror. Information and matter go in, but nothing comes out. For decades, scientists puzzled over this puzzle. What happens to everything that crosses that line? Does the information vanish forever, or does it remain hidden in some way we don't yet understand? Stephen Hawking brought a surprising twist when he showed that black holes might slowly leak tiny amounts of energy in a process now called Hawking radiation. This means that in theory, a black hole could evaporate over unimaginable stretches of time. But if the event horizon lets things out this way, where does the information go? Does it escape? Or is it gone for good? This is called the information paradox, and it keeps physicists awake at night, trying to solve a riddle written in the silence of space. When we took our first real picture of a black hole's shadow in 2019, using the Event Horizon telescope, we didn't see the event horizon itself. What we saw was the glowing ring of hot matter swirling just outside that line. The darkness in the middle, that perfect absence, is where light disappears, slipping past the cosmic gate and falling inward forever. The event horizon isn't just a boundary in space, it's a boundary in knowledge. Beyond it, our math starts to tremble. The rules of physics that work so well on Earth stop making sense. Gravity becomes so strong, space so bent, time so stretched, that we don't have the tools to know what happens next. Yet there's a certain beauty in that. This quiet edge, this cosmic gate, reminds us that the universe still holds secrets we can't yet unlock. It shows us that even in a world mapped by equations and charts, there are still places where mystery sits patiently, waiting for us to wonder. So the next time you think of a black hole, picture that hidden gate, a line in space where everything changes, where light says goodbye, where the known universe hands you gently to the unknown. And perhaps beyond that gate lies something we can't yet imagine, another chapter, another door, or maybe even another beginning. For now, we can only drift to the edge together, press our thoughts softly against the horizon, and dream of what waits on the other side. So here we are, drifting deeper toward the center of a black hole, past the swirling light, past the event horizon, that invisible gate, until we reach the place where the universe's secrets fold in on themselves, the singularity. Singularity. Even the word feels like a whisper, like something you say carefully because it's too big to hold in one breath. In the simplest sense, it's the point at the center of a black hole where all the mass has collapsed into an infinitely small space. But what does that mean? How can something be infinitely dense? How can so much weight and gravity exist in a point smaller than a speck of dust? This is where even the most brilliant minds pause. Physics, the sturdy compass that guides us through so much of the universe, starts to shiver here. The math that tells us how planets spin and light bends can only get us so far. Inside the singularity, our equations break apart like sand slipping through fingers. The numbers run toward infinity, and infinity is a place where logic can't easily follow. Imagine a star, enormous and burning, living out its life in the slow glow of fusion. At its end, gravity overpowers everything else. It collapses. First, the atoms are crushed, then the particles inside the atoms. There is nothing left to push back. Gravity pulls and pulls until all that mass shrinks down to that final point, the singularity. No surface, no inside or outside, just a region where our understanding falls silent. It's a strange thing to think about, a point with no volume, but endless density, an object that is not really an object at all, but a place in space-time where the rules themselves stop working. If you were somehow able to hover just above it, you would find no edges, no glowing sphere, no walls, only the deepest well of gravity, a bottomless drop that pulls everything inward, even time. Physicists sometimes say that the singularity is where time and space swap roles. Outside a black hole, you can move through space freely, forward, backward, left, right. Time moves only one way, always forward. But once you pass the event horizon, time points inward toward the singularity. There is no turning back. Every possible path brings you closer to that heart of darkness. It's as if the future lives there, waiting patiently, pulling you in. What happens when you reach it? We don't know. Some scientists think the singularity might not be a true point at all. Maybe our theories just aren't big enough yet. Maybe deep inside quantum physics, the strange rules that govern particles and energy on the smallest scales somehow save the day, preventing the crush into infinity. Some ideas from string theory or quantum gravity suggest the singularity could be more like a fuzzy knot or a tiny bubble of new physics we haven't discovered yet. Others wonder if the singularity is a bridge, a portal to another universe, or a gateway to another place in our own. These ideas live on the edge of science and speculation, dancing between math and imagination. They show us that even a place of darkness can spark light in the mind. But there is something quietly poetic about the singularity, a reminder that our universe still holds corners we cannot fully see, that there are places so extreme they ask our knowledge to be humble. For all our telescopes and equations, the center of a black hole remains one of the purest mysteries, a tiny region that swallows certainty and gives us wonder in return. Maybe that's what makes it beautiful in its own strange way. The singularity tells us there are limits to what we can know today. It nudges us to keep asking better questions, to listen to what the cosmos might reveal tomorrow, to accept that some riddles do not close the story, but open new pages. So when you picture a black hole's heart, do not think of it as empty or cruel. Think of it as the place where the universe folds in on itself, like a letter waiting to be read, a point where matter, light, and time come together in a secret we have yet to understand. And maybe, just maybe, beyond that whisper of darkness, something unexpected waits. Another clue, another door, a truth we can't yet name. For now, it's enough to know it's there. The singularity, the quiet paradox that reminds us how deep the universe really goes. If you've ever stared up at the stars and felt time slip a little, you've already brushed against what makes black holes so fascinating. They don't just swallow light or bend gravity, they twist the very fabric that holds everything together, space and time. To understand how this works, let's imagine space time as a soft, invisible sheet spread out beneath everything in the universe. Each star, each planet, each of us presses down into that sheet just a bit, making a tiny dip. The heavier something is, the deeper the dip. The sun makes a wide, gentle well that Earth circles around. A black hole is different. It doesn't just make a small dip, it makes a steep, endless pit, so steep that once something falls in, not even light can climb back out. But what's even stranger is that this well doesn't just bend space, it bends time too. Time is not some distant ticking clock, far away and separate from the world. Time lives inside space. It's part of the same cloth. So when a black hole curves space, it curves time along with it. Picture yourself floating far from a black hole, out where the stars feel calm and the pull is soft. Your watch ticks away steadily. 1 second follows another. Nothing feels different. But now, imagine you start to drift closer. You pass planets, old stars, drifting dust, and the pull grows stronger. Time starts to stretch, not in some science fiction way, in a real measured way that scientists have proven with their equations and experiments. Close to the event horizon, that invisible boundary around the black hole, time slows down so much that it becomes a river of syrup. Each second for you feels normal. Your heart beats at its usual pace, but for someone watching from far away, your heartbeat seems to take longer and longer. If you waved at them, your hand would look like it was moving through deep water, each motion stretched and delayed. This idea is called time dilation. It happens because the black hole's gravity is so intense that it warps the pathways that time takes. And here's where it gets really mind bending. From your perspective, you could hover near the edge for what feels like a few hours, then pull yourself back to safety. But for the universe outside, thousands, maybe millions of years could have passed. If you could survive such a journey, and we're just dreaming here, you'd return to find your home changed, your world older, generations past, while you drifted at the edge of a cosmic abyss. It's the closest thing we have to a time machine, hidden in the heart of the universe's darkest places. This isn't just imagination. Scientists have measured how time slows down near heavy things, even here on Earth. GPS satellites circling above us experience time a tiny bit faster than we do on the surface. Without tiny corrections, your phone's map would lead you miles off course. The effect is so small in daily life that you never feel it, but near a black hole, the difference is so extreme that it reshapes our ideas of reality. And what about space? That's twisted too. Imagine a grid drawn on a rubber sheet. Far from the black hole, the grid lines are straight, neat, evenly spaced. As you get closer, the lines bend inward, squeezing together, curving in strange directions. If you threw a rock, its path would twist and spin, not because some invisible hand is pulling it, but because the space it moves through is curved like a funnel. Light itself follows these curves. That's why we see rings and arcs of light near black holes, known as gravitational lensing. The light from stars behind the black hole bends around it, like water flowing around a rock in a stream. Sometimes you can see a single star appear in multiple places at once, an echo of light's twisted journey through warped space-time. Time and space do not like to be tugged and turned this way. They follow the black hole's pull because they have no choice. Inside the event horizon, they twist inward together. Once crossed, the paths of both space and time bend so much that all directions lead to the center, the singularity. To hover near this boundary is to stand on the edge of forever, looking into a place where tomorrow and yesterday lose their meaning. It makes you wonder, if you could look out from the edge, what would you see? Some physicists say you'd see the entire future of the universe flash by in moments, galaxies spinning out their lives, stars being born and burning out, all happening while you feel time slow to a crawl. It's impossible for us to know exactly what that would feel like, but it's a thought that makes the heart quiet. Maybe that's what makes black holes feel more like poetry than physics sometimes. They show us that time isn't a straight arrow for everyone everywhere, that space isn't always flat and predictable. These giants remind us that the universe is elastic. It bends, it ripples, it stretches in ways we're only beginning to see. So tonight, as you lie still, remember that even your seconds are not quite the same as someone else's. Time passes differently in the mountains than at sea level. In the same way, far out in the deep dark, the seconds slip and stretch near these cosmic pits. Maybe one day we'll learn how to ride these folds and see what lies beyond. For now, it's enough to know they exist, a quiet, invisible dance of space and time, rippling out from the shadows of the stars. Let's stay drifting together near the edge of that mysterious place, the black hole. You already know it bends light, stretches time, and curves space until it feels more like a dream than a map. But there's another strange and gentle twist in the tale, one that sounds almost funny until you realize how real it is. It's called spaghettification. Yes, that's the real word some scientists use to describe what would happen if you drifted too close. It sounds like something from a children's story, but it comes straight from the rules of gravity and the quiet way the universe pulls things apart. Imagine you floating at the edge, staring down into the darkness. What would it feel like to slip closer, to surrender to the pull? First, you might not feel much at all. The tug of gravity far from the black hole is strong but not violent. But as you move inward, the story changes. Gravity near a black hole doesn't act the same way it does here on Earth. Here, the difference in pull between your head and your feet is tiny, almost nothing. But near the black hole's event horizon, this difference becomes huge, and that difference is what stretches you. Picture your feet drifting just a bit closer to the center than your head. Because gravity gets so much stronger the closer you get, your feet feel a stronger pull than your head. This means your body is tugged in two directions at once. Your arms, your legs, your spine, they all feel this strange, invisible stretch. It doesn't happen with a snap or a jerk. It happens with an eerie softness, like dough being rolled out, like warm taffy, pulled slowly, endlessly. Scientists once imagined what would happen to an astronaut who drifted in feet first. They'd start to stretch, longer and longer, thinner and thinner, until they looked like a piece of spaghetti, not crushed instantly, but drawn out by the difference in gravity from top to bottom. That's spaghettification, not crushed instantly, but drawn out by the difference in gravity. It sounds scary, but maybe there's something gentle about it too. The black hole doesn't bite or slam, it just pulls, quietly and without mercy. It doesn't do this out of malice. It's just the way gravity behaves when it's pushed to its limit. It's the geometry of space time turned up so high that it twists the ordinary shape of things into something new. This stretching doesn't just happen to people, it happens to everything. Dust, gas, stars, all pulled into ribbons when they stray too close. Astronomers have seen whole stars wander too near a supermassive black hole at the center of a galaxy. From far away with our telescopes and patient eyes, we watch as the star gets torn apart. First, it distorts into a long, thin strand of light. Then, piece by piece, it spirals inward until the black hole swallows what's left. In that last moment, the star is nothing but a river of starlight flowing into darkness. The truth is, spaghettification is one of the reasons black holes fascinate us so much. They remind us that gravity isn't just a gentle hug keeping your feet on the ground. Gravity can become so extreme that it pulls apart the strongest structures, right down to the atoms themselves. But not every black hole would stretch you the same way. Small black holes, the ones born from single stars collapsing, have such steep gravity near their event horizons that spaghettification would happen long before you ever cross that invisible line. One step too close, and you'd feel the difference in pull from head to toe with each breath. Supermassive black holes, though, the giants at the center of galaxies, play by a slightly different rule. Their event horizons are so large that you could cross the point of no return without feeling that extreme stretch right away. You'd drift in, weightless, feeling almost nothing at first. It's only when you approach the singularity itself, deep inside, that the gravity becomes so sharp that it pulls you into that thin, stretched strand. It's strange to think about, isn't it? That something so vast and quiet can have such an effect on the smallest parts of you. You are a collection of cells and atoms and bonds, all holding hands. Gravity tests how strong that bond is. And near a black hole, even those tiny hands can't hold on. But maybe spaghettification is a soft reminder too that the universe is always balancing opposites. Out here, gravity is what keeps you grounded, what holds the moon in its dance around the earth, what lets you walk and rest and dream without drifting away into the sky. Near a black hole, that same force turns fierce, stretching everything it touches into strange, elegant threads. So, next time you twirl a forkful of spaghetti at dinner, maybe you'll smile a little. You'll remember that far away, in the deepest parts of space, there's an invisible pull that can do the same thing to stars, to planets, to anything brave enough to wander too close. Maybe that's what makes black holes feel like riddles. They twist what we think we know, they turn safe things upside down, they stretch the sturdy bonds that hold the universe together, right down to the smallest pieces. And in doing so, they remind us how fragile and wondrous everything really is. So tonight, as you lie still under your blanket of stars, think about the quiet stretch that waits at the heart of darkness. Not a monster waiting to bite, but a force that shapes the cosmos in strange, beautiful ways. Even in the places where light ends, the universe keeps telling its story, sometimes in gentle whispers, sometimes in long, spiraling threads, like cosmic pasta drifting into the night. Somewhere in the hush between stars, a black hole drifts quietly, waiting. Maybe you imagine it as an endless shadow, an unblinking eye in the dark, swallowing anything that dares to come close. It seems so final, so eternal, like a secret that can never be undone. But what if even black holes, with all their invisible weight and gravity, have a soft ending too? What if they do not live forever, but instead breathe out the faintest warmth back into the universe? A long time ago, not so very long in the life of the cosmos, but long for us, a man named Stephen Hawking began to wonder about this. He asked a simple, curious question: could a black hole actually glow? Not with light like a star, not in blazing waves, but in a quiet, patient trickle of heat, so gentle that it might take longer than the life of everything else to fade away. This idea came to him because he saw that the rules we follow every day do not always agree with the rules that black holes seem to live by. He knew that in the tiniest places, the realm of particles and tiny flickers of energy, things are never truly still. Even the emptiest space has whispers in it. Pairs of particles pop into existence for a heartbeat, touch each other, and disappear again. It is a restless dance that never fully stops. Imagine these pairs of particles dancing right at the edge of the event horizon, that invisible boundary around a black hole where the point of no return begins. Most of the time, they appear together, cancel each other out, and vanish, leaving the world just as it was. But Hawking realized that sometimes, just sometimes, one of these particles might slip away from its partner and escape into space. When this happens, it steals a tiny bit of the black hole's energy. The other half, trapped inside the horizon, takes away a piece of its mass. It sounds impossible, a black hole losing mass because of something so small, but that is the magic of it. Over time, these tiny escapes add up. One by one, these quiet flickers drain the black hole's strength, like sand slipping through an hourglass. The process is unimaginably slow. For the black holes we know, it would take longer than the current age of the universe to shrink even a tiny bit. But Hawking's whisper tells us that in the far, far future, when the last stars have gone dark, when galaxies have drifted apart like petals on a still pond, even then, black holes will still be there, sighing out warmth piece by piece. Some people call this Hawking radiation, but I like to think of it as Hawking's whisper. It is the universe's gentle reminder that nothing lasts forever, not even the shadows we thought would never end. Even the deepest cold holds a trace of warmth, a soft breath of energy returning to the dark. And that warmth is not just heat, it carries with it a piece of information, a quiet echo of everything the black hole once held. What happens at the very end? When a black hole has given up its final drop of energy, does it wink out of existence, leaving nothing behind but ripples in space? Or does it release a final burst, a soft farewell that scatters the last secrets it held? No one knows for sure. This is one of those beautiful puzzles that sits on the edge of physics and dream. Some scientists imagine a last tiny pop, like a spark at the end of a candle wick. Others wonder if the universe might hold on to the memory of what the black hole once was, hidden in the waves it left behind. Hawking's whisper changed the way we think about the cosmos. It showed us that the universe does not like absolute endings. It is always recycling, always transforming, always telling new stories from the remnants of the old. A star's death becomes a black hole's birth. A black hole's long, quiet life ends in a breath of warmth that might one day touch another part of the sky. And maybe in some soft corner of the future, that warmth will find you, not to burn or blind, but to remind you that even the coldest, darkest places have a heartbeat, so faint, so slow, but never quite gone. So tonight, as you drift deeper into the calm, think of a black hole far away. Imagine its quiet pull, its endless hush, and then picture that hush giving up the tiniest sigh of warmth, like a secret slipping through your fingers. The strongest shadows, the deepest wells, even they must breathe out their final story someday. This is what makes the universe so gentle, even when it's fierce. It is a place where gravity can stretch you into cosmic pasta, where time can slow to a crawl, where stars collapse and light is lost, and yet in the end, there is always a whisper, a soft reminder that nothing is truly forever, and that every ending is just another way for energy to move on. When you close your eyes tonight, you carry that whisper with you. It hums in the silence, it rests in the spaces between your thoughts, reminding you that you too are part of this cycle, a small warm flicker drifting through the endless dark. Sleep well, stargazer. The black holes are waiting, and somewhere, very far away, they're whispering too. Imagine for a moment that you're holding something precious in your hands. Maybe it's a photograph, maybe it's an old letter, or just a memory that makes you smile when you think of it. Now imagine dropping that memory into a place so deep, so hidden, that no light comes back out. It falls and falls until you can't see it anymore. It's tempting to believe that once it crosses that edge, it's simply gone, erased forever, like chalk wiped from a board. That's what black holes seem to do. They are these patient keepers of secrets, swallowing everything that dares to wander too close. Gas, dust, planets, even starlight. And once something crosses that invisible boundary we call the event horizon, there is no turning back. Light can't escape, matter can't escape, not even time escapes the pull. So it's natural to wonder if everything that goes in can never get out. Does the black hole forget? Does the universe lose a piece of its own story forever? This quiet puzzle is what scientists call the information paradox. It sits at the heart of some of our deepest questions about reality. Because you see, everything in the universe carries information. The swirl of particles inside your coffee cup, the exact way a star flickers, even the simplest speck of dust has a tiny story written into its atoms, how fast they spin, how they bind together, how they might drift apart again. Nature keeps track of these details. It's like the universe has a promise stitched into its fabric. Nothing is truly forgotten. But black holes? They seem to break this promise. When something falls in, the only things we can ever measure from the outside are the black hole's mass, its spin, and its electric charge. All the other information, what exactly fell in, how it moved, what shape it took, is gone from our sight. One moment a star can be swirling beautifully in the dark, and the next, the story of that star seems to vanish behind the event horizon, erased, irretrievable. This idea made physicists uncomfortable. It should. Imagine a library that burns every book the moment you finish reading it. Not just the pages, but every letter, every word, the entire story erased from existence. If black holes truly did this, it would mean the universe could lose parts of itself for good. But nature, as far as we can tell, hates losing secrets. Stephen Hawking, the same mind who whispered to us that black holes might glow faintly and evaporate over time, also wrestled with this paradox. He wondered if the information inside a black hole is really lost, or if, in some strange way, it might find a path back out. Maybe, he thought, the whispers of energy escaping as Hawking radiation carry more than just warmth. Maybe they carry faint echoes of what fell in long ago. Other scientists have wondered if the information is not lost at all, but spread out and hidden at the very edge of the black hole, like a delicate pattern etched into the event horizon itself. Imagine a cosmic recording that holds every detail of everything that has ever fallen inside, written so finely you could never see it, but it's there, woven into the surface like threads of memory. This idea is sometimes called the holographic principle, a hint that maybe the universe works more like a vast, shimmering projection than a solid stage. It's a thought that stretches the imagination. Could everything we see and touch just be a shadow of something more deeply encoded? There are no simple answers yet. This paradox remains one of the most gentle and stubborn riddles in physics. Brilliant minds debate it late into the night, their equations wrestling with mysteries older than starlight. And somewhere in the silence, black holes keep their secrets close, waiting. But maybe that's part of the wonder. A black hole does not roar. It does not boast about what it holds. It simply accepts and folds, holds the memory deep in its invisible heart. It reminds us that the universe can be both generous and shy. It shows us that not all stories have a clear ending. Some drift behind a veil, half whispered, half hidden. So, as you lie here tonight, think of the information paradox like a soft question that floats alongside you. Does the black hole forget, or does it remember in a way we can't yet understand? Does the universe keep its promise to never lose a detail, or is there a secret place where memory can fall away? No one knows for certain, not yet, but that's what makes the stars and the shadows between them so endlessly fascinating. Some truths are meant to keep us curious, to invite us to wonder, to remind us that for every answer we find, another question waits patiently in the dark. Close your eyes for a moment. Let your thoughts drift to the edge of that event horizon. Picture all the stories tucked inside, waiting quietly. Maybe, one day, the universe will find a way to whisper those secrets back to us. Maybe the shadows do not erase what they hold. Maybe they are just another page in a book that is never truly finished. And until then, we listen, we dream, we wonder, and we wait. Somewhere deep in the quiet corners of the universe, in equations scribbled late at night by people who cannot stop wondering, lives a thought as strange as any black hole. It's called a white hole, and if black holes are silent keepers of everything they take in, white holes are imagined as the opposite, the twin that never takes, only gives. It's one of those ideas that sounds like a riddle told by the stars themselves. A black hole is a place where gravity folds space so steeply that nothing, Not even light can climb back out once it crosses the edge. A white hole, though, flips that idea inside out. Imagine a cosmic fountain that refuses to let anything enter, but pours matter and energy out in a constant, impossible flow. Nothing can go in, but everything can burst out. We don't know if white holes exist. No telescope has seen one yet. They remain for now an idea, a gentle dream on the edge of what we know. And like all good dreams, they're both puzzling and poetic. To understand why scientists even think about white holes, we go back to the math. When you look at the equations describing black holes, you find that they don't just allow for this place where space folds inward forever. They also whisper about another possibility, a mirror image where space pushes outward instead. The same math, read in a different light, hints at something that does the opposite of swallowing, something that might spill. Picture a river flowing into a deep whirlpool. You see the water spiral down, pulled into the dark where you can't follow it. Now imagine that on the other side of that whirlpool is a hidden spring. Instead of swallowing, it sprays water back out. It doesn't matter what you throw in, nothing gets in. The water only bursts out in bright, endless jets. That spring is like a white hole, a poetic twin to the whirlpool, each doing what the other cannot. No one knows if nature actually builds these springs in the cosmic fabric, but thinking about them helps us ask bigger questions. What if black holes don't just end in silence? What if deep inside, where space and time twist beyond what we can see, there is another side, a place where the things that fell in might emerge again, reborn as something new? Some physicists imagine that black holes could be connected to white holes through a hidden passage, a tunnel in space time, a bridge called a wormhole. If you've ever read a story about stepping into one place and coming out in another, you've touched this idea already, a shortcut across the universe. Or maybe, some whisper, a path to somewhere entirely different. It is only an idea, a question wrapped in gravity and possibility. But it's beautiful to think about, especially as you lie here tonight, drifting with the stars. The universe is full of these quiet puzzles, black holes and white holes, dark places and bright fountains, each balancing the other in theory, even if we've yet to find the proof in the sky. Sometimes, when scientists follow this trail, they picture the birth of our universe itself. They wonder, could the Big Bang, that first sudden unfurling of energy and light, have been like a white hole moment? A place where, for reasons we may never fully grasp, everything burst outward, unstoppable, unrepeatable, never to be folded back in? Some even suggest our universe might be the other side of a black hole, a white hole opening where something else collapsed long ago. No one can say for sure. That's the sweet, frustrating gift of it. Black holes and white holes live on the edge of what we can measure. They live in the silence behind the stars. And yet, just thinking of them stretches our minds, letting us wander into spaces where the laws we know bend softly, like light around a distant sun. So, as you rest here under your blanket, or beneath your ceiling painted with shadows, picture these twins, the black hole, endlessly patient, swallowing everything that drifts too close, and the white hole, impossible and dazzling, refusing to keep any secret, spilling its brightness into the dark. What would it feel like to stand at the mouth of a white hole? Would you hear it roar, or would it be silent, pouring light like a river that never stops? Would the things it gives back still remember what they once were? A piece of a star, a whisper of dust, a memory long hidden in gravity's hands. It's tempting to wish for answers, but maybe the best part is not having them yet. The universe has its mirrors and mysteries, its shadows and springs, Each new idea reminds us how much we still don't know, and how wondrous it is that our tiny minds can even dream of such things. So tonight, let the thought drift with you. Somewhere out there, maybe beyond the reach of our best telescopes, maybe only in the hush of equations, the other side of a black hole waits. Not a monster, but a mirror. Not an ending, but a gate that opens back out, giving, a soft promise that for every shadow, the universe might hold a light we have yet to see. And you, stargazer, can wonder about it all from your quiet place here on Earth, heart beating gently under gravity's watch, mind floating far past the stars into the secret places where the universe still keeps its greatest surprises. Sleep well tonight, dreamer. The black holes hold what they take, but the white holes remind us that even in the deepest dark, there may yet be a way through, a path where everything comes out into the light once more. There is a question that drifts quietly through the minds of anyone who's ever gazed up at the stars and wondered how far they might really go. If the universe is so wide, so endless, could there be a hidden path through it? A secret tunnel that lets you slip from one side to the other without ever crossing the distance in between. That's what a wormhole is. Not just an idea from science fiction movies and bedtime space stories, but a possibility whispered by the same equations that give us black holes and white holes. A wormhole is a passage through the fabric of space itself, like a soft fold in the cosmic quilt, bringing distant corners together with a gentle twist. Imagine you are holding a sheet of paper in your hands. You draw two tiny dots far apart, one at the top corner, the other at the bottom. If you were an ant, you'd have to crawl the whole length of the paper to get from one dot to the other. But now, fold the paper so the dots touch. Suddenly, the distance disappears. The path becomes shorter, hidden inside the fold you made. That's the dream of a wormhole, a shortcut drawn into the very shape of space and time. Where does this idea come from? It begins with the same mind that gave us black holes in the first place. Albert Einstein, together with a physicist named Nathan Rosen, looked into the math of his general theory of relativity and found that the equations allowed for bridges, hidden tunnels connecting faraway places. These became known as Einstein-Rosen bridges, the first whisper of what we now call wormholes. If you picture a black hole as a well, a steep tunnel that swallows everything, then a wormhole might be like two wells joined at their deepest points, a tunnel from one mouth to the other. One side could be a black hole, the place where things fall in. The other might be a white hole, the place where things burst back out. A cosmic tunnel with an entrance and an exit, a pathway through the impossible. Of course, in real life, it's not so easy. Nature, it seems, loves to make puzzles harder to solve. If wormholes do exist, they might be unstable, trembling open for only a heartbeat before collapsing shut again. Anything passing through would be crushed or trapped. Some physicists wonder if strange forms of matter, so called exotic matter with unusual properties, might hold a wormhole open like a sturdy bridge. But so far, we haven't found such matter, not yet. Still, the idea lingers. It lingers because it's beautiful. It tells us there might be hidden doors in the universe, secret ways to cross oceans of light years in a single step. No rockets, no fuel, just a tunnel through space itself, a door that opens not out into the cold void, but into another place entirely. Some scientists wonder if wormholes could connect not just two points in our universe, but two different universes altogether, a bridge between realities. Or maybe they might link two moments in time. Step through, and you find not just another star, but another century, another beginning. It is a thought so big that it feels almost like a story you'd hear while drifting off to sleep. It wraps you in wonder. It reminds you that space isn't just emptiness, it's a living fabric, soft enough to bend, maybe even soft enough to fold in ways we can barely imagine. No one has ever seen a wormhole. No telescope has found one glimmering on the edge of a galaxy. No probe has flown into one to test if the other side really waits. But the math says it's possible, and in science, sometimes that's the first breath of truth, a gentle promise that one day our minds or our instruments might find a way to catch up with what the universe has already written into its code. Think for a moment about how many times you've wished you could skip the long roads, the endless waiting. A wormhole is the universe's version of that wish, a dream that somewhere, hidden in the deep dark, there might be a doorway where distance falls away and all the far places come close. Even if wormholes remain only a dream, they do something precious. They remind us how much we still don't know. They show us that curiosity is a tunnel, too, one that connects us to the next question, and the next, and the next, drawing our thoughts further than our feet could ever go. So, as you lie here tonight, wrapped up and drifting, think of this: somewhere in the ink black sky, maybe beyond the pull of our strongest telescopes, maybe just on the page of a scientist's notebook, a wormhole waits to be found, a bridge where light and time and gravity twist into a quiet promise that the universe is more connected than it seems, and that even the longest journey might have a secret shortcut if you know where to look. And you, with your soft wonder and sleepy eyes, are part of this story too. Your questions stretch out like little tunnels of their own, folding the distance between what you know and what you long to find out. You may never step through a wormhole, but in your mind, you already do. Every time you dream about what might be waiting on the other side. Sleep easy, dreamer. The universe is wider and softer than it looks, and tonight you've wandered through the folds. Sometimes, to get closer to the edge of what we know, we need to dream a little bigger than what we can see. We need stories that take the cold equations of physics and breathe warm, flickering life into them. We need images that linger behind our eyelids when we drift off to sleep. Images so real, they feel like memories from another universe. In 2014, a movie gave the world one of those images: a black hole named Gargantua, spinning endlessly in the vastness of space, its glowing ring bending and folding light in ways that seemed almost too beautiful to be true. Maybe you've seen it, that dark circle wrapped in a bright halo, floating like an eye in the cosmos. It came from a story, but it was shaped by real science too. Interstellar was not just another science fiction film about rockets and stars. It was a collaboration between artists and scientists, dreamers and mathematicians, all asking the same question: what would it look like if we could really stand near a black hole? What would we see if we dared to drift close enough to its swirling edge? One of the people behind that question was Kip Thorne, a physicist whose name is whispered among the stars for his work on gravity and black holes. He didn't just advise the filmmakers, he brought them the language of relativity, the curves of space and time, the gentle but relentless pull of equations that describe what happens when mass folds reality in on itself. If you remember the film, you might recall how Gargantua didn't look like the black holes we'd seen in other movies or on book covers. It didn't swirl like water down a drain or glow like a neon sign. Instead, it seemed to hover in a kind of delicate dance, a circle of darkness surrounded by a halo of light that rose above and dipped below, bending in an almost impossible loop. This wasn't just special effects, this was science made visible. Kip Thorne and the visual effects team worked side by side, turning pages of math into a simulation so precise it ended up in scientific papers. When they fed the equations into the computers, what came out surprised even them. The light from the disk of hot gas swirling around the black hole didn't just wrap neatly behind it, it rose up and over, dipping around the sides like a crown, bending back toward the observer. That happens because light, like everything else, must follow the curves that mass makes in space. Near a black hole, those curves become extreme, almost like a funhouse mirror stretched out across the universe. Light from behind Gargantua was bent forward, light from below was lifted up, and so what we see is not just the front of the swirling disk, but the back and the sides, all at once, a cosmic illusion born from the deepest truths of gravity. Imagine for a moment that you are there, drifting just outside Gargantua's event horizon. The pull beneath you is so strong that time itself slows down. Your heartbeat feels the same, but out in the wider universe, years pass in the space between your breaths. The light from the accretion disk blazes, circling you like a ring of fire. You're not falling yet, just hovering at the edge of forever. In the film, Gargantua isn't just a threat or a monster waiting to swallow spaceships. It is a gate, a door to possibility. It holds the answer to a mystery that can only be glimpsed if you dare to drift close enough to see it in motion. And even if that part of the story stretches what we know, the tesseract, the fifth dimension, the bookshelf in the void, it does something important. It reminds us that stories can carry science to places that equations alone sometimes cannot reach. Kip Thorne said later that working on Interstellar was one of the most beautiful ways he'd ever seen his life's work come alive. He saw audiences staring into Gargantua's ring of light with a kind of awe that no diagram in a textbook could ever inspire. For a moment, millions of people imagined what it might feel like to stand near a black hole, to feel time slip and stretch, to wonder what waits beyond that ring of darkness. Maybe that's the secret gift that stories like Interstellar give us. They don't pretend to be the final answer. They don't say this is exactly how it is. Instead, they whisper, look at what could be. They show us a window into ideas so vast and strange that they can't help but stick to our dreams long after the credits roll. And here's something wonderful to remember: Gargantua's shape wasn't just fantasy. Years after the movie, when astronomers finally captured the first real image of a black hole's shadow using the Event Horizon Telescope, they saw something strikingly familiar: a dark center, a ring of fire, light bent into a soft, glowing circle, just like the equations had promised. What once lived only in a scientist's mind and a filmmaker's vision was now a photograph pinned to the wall of reality. So tonight, as you lie here drifting near sleep, you are part of that beautiful circle too. You carry stories and questions in your mind. You imagine what it might feel like to hover at the edge of a black hole, to watch the light curve around you, to feel time slip through your fingers like sand. You are proof that wonder doesn't belong only in science or only in stories. It belongs right here, where the two meet, in your imagination. Sometimes what we see in our dreams helps us ask better questions when we wake. Sometimes a movie shows us what our eyes may never see, but what our hearts can hold all the same. And in that warm place between science and imagination, you find something truer than facts alone: the promise that there is always more to explore, more to picture, more to dream about as you drift further into the stars. Sleep well, stargazer. Gargantua waits only in stories, but the questions it leaves behind are yours to keep, yours to wonder about, yours to carry softly into the dark. Every now and then, when you let your mind drift far enough, You land on a question so big, so strange, it almost hums like a secret in the dark. One of those questions is this: could a black hole be more than just an end? Could it be a beginning, too? A cosmic seed, planting something new on the other side of reality? It's the sort of thought that arrives when you're lying under the stars, the night pressing gently at the edges of your blanket. You look up and wonder, what if that distant, invisible dot, that hidden black hole, is not just swallowing up matter, but sending it somewhere else, somewhere we can't yet see? Scientists call this the idea of baby universes. Imagine that every black hole in its heart holds a singularity, a point where all the known rules of physics break down, where gravity grows so strong and space and time bend so sharply that they nearly fold in on themselves. Some thinkers wonder if that fold is more than a trap. Maybe it's a tunnel. Maybe the pressure and density create a tiny new universe, sealed off from ours, drifting out like a soap bubble from the tip of a wand. If that's true, then every black hole is not just a graveyard for old stars, but also a nursery. Our own universe could have been born this way, the result of some ancient, massive black hole collapsing in a parent universe long gone. It's a strange thing to picture, a sort of cosmic family tree branching out in every direction, one universe giving birth to another, again and again, endlessly. It's not easy to wrap your mind around it, is it? The very words we use, universe, singularity, infinity, start to slip away when you try to imagine what comes before a beginning or after an end. And yet the idea is comforting in its own quiet way. Nothing wasted, nothing truly lost. Matter falling into a black hole here could become stars and planets and galaxies somewhere else, carried through a kind of hidden cosmic womb. Some theories call this cosmic inflation or eternal inflation. They suggest that the universe is always budding off new spaces, like leaves unfurling on a branch that never stops growing. Maybe black holes are just one of the ways this happens. Maybe each singularity punches a hole through the fabric of our reality and stitches a new patch on the quilt of existence. Imagine standing at the edge of such a portal. You'd look down into the event horizon, the point of no return, and know that once you crossed, you'd be pulled deeper than time itself. But what if, instead of being crushed out of existence, you emerged somewhere new, light years and eons away, in a brand new bubble of space? Maybe it would look like our universe did in its infancy, hot, dense, roiling with energy, waiting to expand and cool and form stars and worlds of its own. Of course, no one knows for sure. The truth hides behind layers of math and possibilities we can't yet test. Peeking inside a black hole is impossible, at least for now. The light can't escape, and neither can our instruments, so the secrets stay folded deep inside. But sometimes that's part of the magic. Not knowing is an invitation to imagine, to let your mind wander farther than your eyes can see. In this quiet moment, think about what it means if this idea is true. Somewhere, right now, a black hole could be giving birth to an entire universe, a place where galaxies swirl and stars blaze to life, where planets spin and oceans shimmer under alien suns. Maybe in one of those newborn universes, someone lies awake under their own unfamiliar sky, looking up and wondering if their cosmos was born from a black hole too. It's a lovely thought, isn't it? That every end could hold a beginning, that what looks like darkness and destruction might be a doorway. It reminds us that even the things that seem to swallow light could be giving more than they take. Maybe that's the greatest lesson black holes offer us, that even in the places where everything collapses, something beautiful and surprising could be waiting, hidden beyond the veil. So, as you settle deeper into your pillow, let your mind float through that idea. Picture black holes as seeds drifting through the dark soil of space, splitting open and blooming new universes. Maybe our own night sky is the garden grown from countless generations of these cosmic seeds, each one linked to the next in a chain that stretches back farther than we can ever know. And when you wake tomorrow, the stars will still be there, scattered like tiny reminders that we're part of something so much bigger than our eyes alone can show us. Let that thought be a gentle lullaby tonight. Every ending carries a hint of a beginning, and sometimes what we fear is the edge might just be another door. Sleep well, stargazer. The seeds of the cosmos are still sprouting, even as you dream. Some puzzles are so big, so tangled up in the fabric of everything, that they feel almost alive. Black holes are one of those puzzles. They tug at the corners of what we know, pulling our two greatest scientific stories into a knot we still can't quite untie. That knot has a name: quantum gravity. You see, we have two big maps for how the universe works. One is called general relativity. It's the map that shows how planets orbit stars, how galaxies swirl, how gravity pulls on everything from your cup of tea to an entire galaxy cluster. Relativity is beautiful and grand and sweeping. It describes the stage and the dance, the curves of space, and the flow of time. Then we have another map. This one is tiny and jittery and full of surprises. It's called quantum mechanics. Quantum mechanics explains how particles appear and vanish, how they can be waves and points at the same time, how they dance to rules that sound more like riddles than laws. This map shows us the grains of existence: atoms, quarks, forces that flicker and flash at the smallest scales. Both maps work brilliantly in their own domains: relativity for the vast and massive, quantum mechanics for the tiny and energetic. But inside a black hole, these maps clash. They overlap in the worst possible way. Right at the singularity, that point of infinite density, where a star's core has collapsed to almost nothing, our neat separate maps run together like watercolors. The equations break down. Infinity appears in places it shouldn't. What should be solid ground becomes quicksand. Scientists call this the problem of quantum gravity. They're searching for a single map, a theory that weaves together the smooth curves of space time with the jittery jumps of particles. A map that shows how gravity works, not just with big planets and stars, but with the smallest bits of matter, too. Think of it like this: if general relativity is a sweeping painting of the night sky, and quantum mechanics is a sketch of tiny fireflies flickering in the dark, quantum gravity would be the hidden drawing that shows how the fireflies paint the sky itself. It would explain how the universe knits together at every level, how the fabric holds when pulled tighter than tight, inside the heart of a black hole. People have been chasing this hidden map for decades. Some believe it lies in string theory, the idea that particles are not points, but tiny vibrating strings. Different vibrations create different particles, like notes from the same instrument. Others look to loop quantum gravity, a theory that imagines space time itself is made up of tiny loops, like a woven fabric. Both ideas are young and unfinished, full of hope and confusion. And maybe that's okay. Sometimes, not having the full map means we keep exploring. We imagine wormholes and fuzzballs and holographic universes. We test bold ideas at particle colliders and in the math scribbled late at night on chalkboards. We keep listening for clues, like the gentle hiss of Hawking radiation or the sudden flash of gravitational waves from colliding black holes. If someone does find the hidden map, It might tell us what a singularity really is. Right now, it's a word that stands for here be dragons, a place where physics throws up its hands and says, I don't know. But a working theory of quantum gravity could show us what happens to the matter that falls in. Does it get crushed to nothing? Does it spread out in a new dimension? Does it leave an imprint on the fabric of space time itself? Imagine what it would mean to peek behind that curtain, to stand at the edge of a black hole and see the singularity not as a monster, but as a doorway, shaped and explained by this deeper understanding, a hidden order inside the chaos. It's humbling to remember that we're still drawing this map, that our greatest minds, Einstein, Hawking, and thousands more, built the roads that got us this far. But the next step might come from someone you've never heard of. Maybe they're awake right now, under the glow of a desk lamp, scribbling equations and dreaming of black holes blooming into universes. As you rest here tonight, think about the maps we carry inside us. Questions are maps too. They show us where to look next, where the blank spaces are. Black holes are reminders that the universe still keeps secrets, that beyond the lines we've drawn, something breathtaking waits to be discovered. So let your mind drift there for a moment. Picture the singularity not as a dead end, but as a signpost, a marker that says, more to come. Maybe, as you sleep, the universe is already whispering hints to someone who'll someday draw that missing piece of the map. And maybe, just maybe, the map will lead us deeper than we ever dreamed. Sleep softly, fellow explorer. The puzzle isn't finished yet, and that's the most wonderful part of all. When you look up at the stars on a clear night, you're seeing light that's traveled millions of years just to brush your eyes. It's easy to forget that stars aren't forever. They live, they burn bright, they die, and sometimes when they die, they leave behind a mystery so deep it reshapes the sky around them, a black hole. But what if these black holes, these hungry giants that swallow everything in reach, are not the end of a story, but just another beginning? Some scientists like to wonder if black holes might be cosmic composters, quietly turning yesterday's stars into tomorrow's light. Let's sit with that thought for a moment. In a forest, a fallen tree doesn't just disappear. It sinks into the soil, breaks down, feeds tiny creatures, grows mushrooms, and slowly becomes rich earth. And from that earth, a new sapling might stretch up toward the sun. Life folds into itself, recycles, breathes out something new. Black holes might be doing a similar thing on a scale so massive it's almost impossible to grasp. Imagine a star. For billions of years, it shines by fusing tiny particles together, making heavier elements deep in its core. When its fuel runs out, the balance tips, gravity wins, and the star collapses in on itself. Sometimes that collapse is so violent it tears open space, leaving behind a black hole, a place where matter vanishes from our sight. But matter doesn't like to be erased. One idea is that everything pulled into a black hole isn't truly destroyed. Instead, it gets crushed, twisted, transformed into something so small, so dense, that our normal physics can't explain it anymore. But the energy and information that once made up that star, all its atoms and particles and heat, still exist in some form. Here's where the idea of cosmic recycling comes in. Some physicists suggest that over unfathomable spans of time, black holes might leak tiny bits of this trapped information back into the universe. Hawking radiation, that gentle glow we talked about, might be more than just a sign of a dying black hole. It could be a tiny cosmic exhale, a whisper of starlight returning to the dark. Other theories imagine something wilder. What if the matter pulled in by a black hole doesn't just vanish or drift back out slowly, but bursts out somewhere else? maybe in another corner of our universe, or even in a brand new universe altogether. Some ideas tie this to white holes, the theoretical opposites of black holes. They can't be entered, only exited. So maybe every black hole is the mouth of a tunnel, a funnel through which dying matter gets a second chance to shine. It's comforting in a way, isn't it? To think that the universe might be a patient gardener, never truly wasting anything. Stars collapse, feed black holes, and those black holes in turn feed the seeds of new creation. Galaxies swirl around supermassive black holes, drawn in by their immense gravity. Stars are born in the dense clouds that gather near them. Entire solar systems might blossom in the shadows of these cosmic monsters. Look at our own Milky Way. At its center sits a giant black hole called Sagittarius A*. Around it, stars dance in tight orbits, some flung out at incredible speeds. The gravity here doesn't just pull, it shapes, molds, stirs the pot of gas and dust where new stars ignite. The very thing that swallows light can, at the same time, help create the conditions for new light to be born. It's a beautiful paradox. Destruction and creation aren't opposites, they're partners. Each one feeds the other. Nothing is wasted, only changed. So when you think about black holes, don't picture them as empty pits of doom. Picture them as cosmic compost heaps. Dark, yes, but rich with potential. They remind us that the universe is not just a place of endings, but of endless beginnings. That starlight doesn't simply flicker out, but might one day flicker back in, changed, recycled, reborn. And maybe that's true for us too. Maybe the atoms that make up your bones and the breath you're taking right now were once forged in a star that died long ago. Maybe a black hole helped scatter that stardust across the galaxy, mixing it into clouds that drifted until our sun was born, until the earth formed, until you were here listening under this same vast sky. Tonight, as you drift off, think of this gentle truth that we are all part of a cosmic recycling plan, too grand to ever fully see. Black holes, stars, people, dreams, all caught in a dance of becoming, dissolving, and becoming again. Sleep softly, stargazer. Somewhere out there, the universe is composting the past and planting seeds for the future. And we, tiny and bright, are part of that endless garden. If your head feels full of stars already, don't worry, mine does too. Black holes are strange enough on their own, but the more scientists try to understand them, the stranger they become. Some theories whisper that what we thought we knew is only a shadow of something much more peculiar and beautiful hidden beneath the surface of reality. So tonight, let's wonder about fuzzballs and holograms. Not the kind you'd find in a sci fi movie, but real ideas from some of the brightest minds trying to solve the deepest puzzles. Let's start with fuzzballs, a name that almost sounds cute. It comes from string theory, which you can imagine as an attempt to describe the tiniest building blocks of our universe. Instead of tiny dots, it says everything is made of vibrating strings, minuscule loops of energy, humming and dancing at the edge of what we can measure. When physicists first tried to understand what happens inside a black hole, they imagined it as a singularity, a point so infinitely dense and small that the laws of physics just crumble around it. But that leads to a problem, the information paradox. Remember that from our earlier drift. If nothing can escape a black hole, what happens to all the information, the story of every particle that falls in? Some string theorists think maybe there is no true singularity at the center after all. Instead, they suggest that a black hole might actually be a fuzzball, a tangled fuzzy sphere of vibrating strings. It's still incredibly dense, still a place where space and time do strange dances, but instead of collapsing to a point, all the matter and energy spread out like a cosmic hairball. I know, not the prettiest image for bedtime, but there's something sweet about it too. It means the information that falls in might get tangled up in that fuzz, never really lost, just hidden in a new form. This idea helps resolve the paradox in a gentle way. Instead of the universe deleting its secrets, it wraps them up in fuzzy layers. No harsh singularity, no terrifying abyss, just a tangle of energy that might eventually radiate the story back out, bit by bit. And then there's the holographic universe, an idea so strange that even physicists admit it feels like a dream. You've probably seen a hologram before, a flat picture that appears three-dimensional when you shine light on it just right. Now imagine that our entire universe works like that everything we touch, see, and feel as solid and three-dimensional is actually a projection from something two-dimensional at the edges of space. This thought first grew from studying black holes. When physicists calculated how much information you could hide inside a black hole, they realized something odd. It depends on the surface area of the event horizon, not the volume inside. That's like saying the secrets inside a room depend not on how big the room is, but just on the size of its walls. It was such an unexpected twist that people wondered, what if that's not just true for black holes? What if the whole universe is like that? A cosmic hologram where everything inside is a projection from a distant boundary we can't yet see. It's hard to picture, isn't it? Here you are, lying back, feeling your blanket, hearing your breath, knowing your feet rest solidly on the floor. And yet, some of our best equations suggest that all this might be a shimmering illusion, that the deepest truth of our reality is painted on a faraway surface, while we live in the dream of its glow. But instead of feeling unsettling, I think it's oddly comforting. It reminds us that reality is more than what we can hold, that we are stitched into a fabric of dimensions and possibilities we don't yet understand. If we are holograms, then each of us is a tiny echo of something bigger, connected in ways we haven't yet imagined. Fuzzballs and holograms don't mean you aren't real. They mean that the story of who you are might be richer, more layered, and more connected to the cosmos than you ever guessed. Maybe your thoughts, your laughter, your quiet worries at night are threads in a much bigger tapestry, one that stretches all the way to the edges of time and back. So if your eyelids are getting heavy now, let this strangeness soothe you. Maybe the universe is soft and fuzzy inside its darkest places. Maybe your life is more than a flicker in the dark. Maybe, just maybe, you are the hologram and the light shining through it all at once. Rest easy, stargazer. Somewhere out there, black holes spin their secrets into fuzzy balls of energy, and the universe projects its dreams onto the soft night sky above you. Nothing is ever truly lost. Everything is connected, and your place in this cosmic story is safe and wondrous forever. Sometimes the universe feels like it's playing a game of cosmic peekaboo. It hides its biggest wonders behind veils we can't pull back with our bare eyes. Black holes, especially, are the masters of secrets. By their very nature, they swallow light, leaving nothing for us to see directly. So, how do we know they're even there? Tonight, let's cozy up with the story of the shadows they leave behind, the quiet hints that something impossibly heavy is sitting in the dark, bending the light around it. This is where human curiosity shines brightest, even in the deepest shadows. Imagine for a moment that you're staring at a campfire in the middle of a pitch black forest. You can't see the trees beyond the circle of light, but you know they're there because the fire's glow fades into darkness. In a similar way, Black holes reveal themselves by the light they refuse to let go, not by the light they send out, but by the light they trap forever. The space around a black hole is often buzzing with energy. Gas and dust spiral toward it, pulled in by its gravity, heating up until they glow fiercely. These glowing rings of gas are like the universe's neon sign. Something hungry lurks here. But right at the center of that bright swirl is the hole itself, a shadow where even that furious light cannot escape. That's what scientists call the shadow of a black hole. For decades, this idea stayed mostly in our minds, equations and chalkboard scribbles. People painted it in words, and artists imagined it in brushstrokes, but no one had ever actually seen this shadow until not so long ago. Back in 2019, the Event Horizon Telescope, a collaboration of telescopes scattered all around our little Earth, gave us the first direct glimpse of this elusive darkness. It wasn't a telescope like you keep on your windowsill. It was 8 observatories spread across the globe, working together like pieces of a giant mirror the size of our planet. Scientists linked them to collect whispers of radio waves that had traveled across millions of light years, bent by the fierce gravity of a monster in the center of a galaxy far, far away. When all those faint signals were stitched together, what they revealed was astonishing: a blurry, glowing donut with a dark center. That orange ring you've probably seen. It's not just a pretty picture, it's a silent, powerful proof that black holes are real and that our theories about them might be closer to the truth than we ever dared to hope. In that blurry ring, you can see the bright edges of light whipped around by gravity, orbiting the black hole at nearly the speed of light. And in the middle, you see the shadow, not the hole itself, but the place where light has vanished beyond the event horizon, never to come back. It's like seeing a footprint on a trail you thought was empty, a sign that something massive and invisible has passed this way. There's something beautifully human about this discovery. For all our fragile bodies and short lives, we've learned how to see what can't be seen with our eyes alone. We've learned to build eyes big enough to peer across the universe and glimpse a ghostly outline left by something that wants to stay hidden. The black hole they imaged sits in the galaxy M87, 55 million light years away. Think about that for a moment. The light that made that picture started its journey when ancient human ancestors were just figuring out how to walk upright on 2 legs. That faint signal traveled through space all that time, past colliding galaxies and drifting stars, until it finally brushed against our planet's telescopes. We gathered those cosmic crumbs and turned them into the first portrait of a black hole's shadow. And you know what's even sweeter? People all over the world work together to make this possible. Different countries, different languages, different pieces of the puzzle. Each one needed to see the shadow clearly. It's proof that when we're curious together, when we share our questions instead of hoarding them, we can see deeper into the darkness than we ever could alone. The shadow reminds us that we don't have to fear the unknown. Sometimes it's the shadows that help us see the shape of things we could never touch directly. A soft outline, a hint of the impossible, telling us we're not done learning yet. So, next time you see that blurry orange ring on a phone screen, a magazine, or drifting through your thoughts as you lie in bed, remember you are looking at the mark of something that defies our understanding. You're seeing proof that even in the deepest darkness, there are clues. There is always a way to glimpse what hides beyond. Drift deeper now, stargazer. Let that shadow remind you how beautiful the hidden can be, how our questions carve windows into the night, and how sometimes all you need is a gentle ring of light to know that even the darkest places are part of a story too vast, too wondrous to ever stop telling. It's a comforting thought in its own strange way that while we drift through our tiny patch of the universe, we're being quietly held in place by a giant we can't see. Almost every galaxy we know, from swirling spirals to massive ellipticals, has a secret at its heart, a supermassive black hole. Not just any black hole, but a monster millions or even billions of times heavier than our sun. These are not the lonely, drifting black holes made by single collapsing stars. These are anchors, so heavy they shape the dance of entire galaxies. Picture our Milky Way, that graceful swirl of stars stretching across the night sky. It looks calm, even delicate when we glimpse it on a clear night. But hidden deep in the middle is Sagittarius A star, our own supermassive black hole. It sits there in the dark, quietly spinning, quietly holding everything around it together. Its name sounds like a riddle, Sagittarius A star, but really, it's just the label we gave this patient giant. Scientists believe Sagittarius A is about 4 million times the mass of our Sun. That number is so big, so beyond everyday experience, that the mind almost skips over it. But maybe this will help. If you could somehow scoop up the Sun with all its fierce heat and swirling plasma, and then do that 4 million times, you'd still only have a rough estimate of what this black hole weighs. Yet, for all its monstrous heft, Sagittarius A doesn't roar. It hums. It sits in the dark, mostly silent, surrounded by clouds of gas and stars that swoop around it like fireflies around a porch light. Every so often, a stray star or clump of gas gets too close, pulled in by gravity too strong to resist. The matter spins faster and faster, heating up, glowing like a cosmic whirlpool before it disappears forever past the event horizon. It's wild to think that these monsters do not destroy galaxies. They shape them. Without these silent anchors, galaxies might never have formed into the elegant spirals and smooth ellipses we see through telescopes. Long ago, in the young universe, black holes likely fed on giant clouds of gas, growing bigger and bigger, gathering more mass until they could tug entire swarms of stars into their orbit. In this way, supermassive black holes act like seeds. From a single tiny speck of unimaginable weight, a garden of stars blooms around them. And they are not rare. Everywhere we look, they appear. In the center of Andromeda, our nearest large neighbor galaxy, there's another monster waiting. In M87, the galaxy that gave us our first image of a black hole's shadow, the central black hole is 6.5 billion times the mass of the Sun. Think of that, a single object heavier than billions of suns combined, sitting so far away that its heartbeat takes centuries to feel. You might wonder if these giants could ever come drifting through the neighborhood, knocking stars loose, or gobbling up planets. But these supermassive black holes are not wanderers. They stay put. They are the anchor that keeps the galaxy's spiral arms from flying apart. Without them, the stars might not dance in graceful orbits. Without them, the delicate structure of a galaxy might never hold. Scientists spend years peering into the center of the Milky Way, tracing the orbits of stars that zip around Sagittarius A like tiny test particles. These stars act like breadcrumbs, showing us where the monster hides. As they slingshot around that invisible mass, their paths whisper the same truth over and over again. Something huge is there, something dark, something so dense that it can bend their light, their speed, their entire existence. And, and yet, in all its silence, there's a gentleness to this giant. Sagittarius A could be noisier, brighter, more violent. Some galaxies have black holes that rage, sending out jets of particles across millions of light years. But ours is mostly quiet, just a slow swirl at the heart of our home, humming to itself while the solar system drifts serenely in the outskirts. Next time you look up at the Milky Way, stretching across a dark sky, remember that deep in the glow, beyond the stars and the dust, sits a patient anchor, keeping us in place. It reminds us that the universe is not just chaos and drift. There is structure, there are centers, there are giants that cradle entire families of stars, including the sun that warms your face and the earth that holds you now. So, drift off tonight with this thought tucked under your pillow. Somewhere far away in the dark, our galaxy's gentle monster spins and waits, a quiet guardian at the heart of everything we see. A reminder that even in the vast, lonely blackness, there can be something steady to hold us close. When you think of black holes, maybe you picture the giants, the monsters at the center of galaxies, weighing millions or billions of times more than our sun. Or maybe you imagine the stellar ones, born from collapsing stars, scattered here and there like cosmic punctuation marks. But there's a quieter idea, a tiny possibility, drifting around the edges of science and imagination: primordial black holes. Primordial means ancient, older than old. If they exist, these black holes were not born from stars. They didn't come from the collapse of something large and burning. Instead, they might have been born in the very first breath of the universe, the Big Bang. In that first moment, everything was hot, dense, expanding faster than we can truly picture. In that chaos, in those first fractions of a second, little pockets of matter could have clumped together. If a pocket was dense enough, heavy enough, gravity could have squeezed it into a black hole right then and there. Imagine that, a black hole smaller than a mountain, hiding in the dark. Some primordial black holes might be the size of an asteroid, or even smaller, yet their weight would be enormous for something so tiny. A teaspoon of one would weigh as much as a mountain, a single handful of that invisible darkness, heavier than anything your mind can hold. No one has ever seen one for certain. They're just an idea, a gentle possibility that makes some scientists lean forward in their chairs late at night, tracing the shape of the universe in their minds. If they exist, primordial black holes could be everywhere, scattered like lost seeds through the cosmic garden, drifting alone through interstellar space, ancient and cold, older than the oldest star. Some think these tiny seeds might help answer other big questions. There's a mystery in our universe called dark matter. When astronomers look at galaxies, they see that there's not enough visible stuff to keep everything together. The stars should fly apart, the spirals should unravel, but they don't. Something invisible must be holding them in place, a hidden weight that outweighs everything we can see. Some wonder if primordial black holes are that missing weight. Billions upon billions of them, so small they slip between our instruments like ghosts, but together adding up to enough mass to steady the cosmic dance. It's a beautiful idea that the universe's hidden glue might be tiny black holes, each a remnant from the dawn of time. Imagine them wandering between stars, drifting through the vastness, never colliding with planets or suns, just floating forever. They would be nearly impossible to find. They don't shine. They don't make a sound. You could pass right through one shadow and never know. Some scientists search for signs. They watch distant stars, waiting to see if their light flickers just a bit when a tiny black hole passes in front. They listen for the gentle whisper of gravitational waves, ripples in space-time that might be caused when two primordial black holes collide. So far, the evidence is thin, like footprints that fade in the wind before you can measure them. But the search goes on. Think about this. If these ancient seeds do exist, then the universe has been carrying them for nearly 14 billion years. Tiny pieces of the past, still here, drifting unnoticed while galaxies grow, stars are born and die, and planets spin silently. They are survivors from a time when physics was raw and wild, when the universe was so young it didn't yet know what it would become. There's something comforting in the thought that even in a place as vast and unpredictable as the cosmos, some things endure, some things last. Some things are so small, so quiet, that they escape the churn of time. They remind us that the universe is not always about grand explosions and massive giants. Sometimes its secrets are soft and hidden. Sometimes they fit in the palm of your mind. If you look up at the stars tonight, you'll see the past in their glow. But if you close your eyes and imagine what you cannot see, the tiny black holes drifting through the dark, you'll be peeking into an even deeper past, a secret stitched into the fabric of everything, a whisper from the universe's first heartbeat, still echoing through the silent dark. So, let this thought keep you company as you drift off. Somewhere out there, ancient seeds may be gliding through the endless night, invisible, eternal, patient, holding the memories of the beginning, reminding us that sometimes the smallest things carry the greatest mysteries, and maybe, just maybe, they're part of the same quiet gravity that holds you here now, warm and safe under the blanket of the stars. Let's sit with a question that so many stories love to ask, and that so many curious minds replay when they stare up at the night sky. Could you survive falling into a black hole? Could a person, just drifting there at the edge, slip through the event horizon and somehow keep going? It sounds like pure science fiction, and in many ways it is. But sometimes exploring the impossible is exactly what makes the universe feel so wide open. Picture yourself standing near the edge of a black hole, or maybe you're floating there, your mind wrapped in a gentle, impossible suit that keeps you safe from the heat, the radiation, the violent pull. We'll pretend you're protected, just for a moment. Outside the event horizon, you would feel the tug. Gravity would pull at every part of you, stronger and stronger the closer you get. The stars around you would distort, light bending and wrapping into rings that circle the black hole's darkness like a cosmic halo. Time would slow down for you. If a friend watched you from far away, they'd see you frozen at the edge, lingering forever in that moment. But to you, time would feel normal. Your heartbeat, your breath, your drifting thoughts all moving along. And once you crossed that invisible line, the event horizon, the universe behind you would fade. No signal could reach back out. No message could escape. It's not a wall, not something you'd feel with your fingertips, but a boundary you'd only realize you'd crossed, because suddenly everything behind you would be gone. What happens next? The honest truth is, we don't know. The math tries to whisper answers, but the equations break down at the singularity. Some say you'd be stretched, spaghettified, as the scientists like to call it. If you fell feet first into a stellar black hole, the pull at your feet would be so much stronger than at your head that you'd be pulled long and thin like a cosmic noodle. But what if, instead, you drifted into a supermassive black hole? There, the tidal forces might be gentle, at least at first. The event horizon is so far from the center that you wouldn't feel much difference from head to toe. You could float for a while, suspended in darkness, in the deepest cradle of gravity known to the cosmos. Inside, time and space twist together like threads spun too tight. Some theories say you'd see the whole universe's future play out in a heartbeat, stars aging and dying, galaxies drifting apart, light itself stretched and bent until it becomes something you can't even name. Maybe you'd see the edge of time. Maybe you'd glimpse the universe's next shape. Or maybe you'd see nothing at all, just darkness wrapping you in a quiet so complete that your mind would have to invent its own stars to fill it. Could you land somewhere? Could you punch through to another place, another time? This is where imagination likes to roam. Some scientists dream of black holes linking to white holes, cosmic doorways that don't crush, but instead pour you out somewhere else. Maybe you'd tumble into a newborn universe, particles and light scattering like fireflies. Maybe you'd emerge near another black hole, far across the cosmos, drifting out into a different sky. It's not likely, not with what we know now. Our physics says that the singularity, that tiny point in the center, is a place where everything we understand falls apart. Matter, energy, time, space, all mashed into a single knot, so tight that our rules stop making sense. But our physics is still growing, still learning. Maybe one day the equations will open a door we can't quite see yet. So, if you could survive the crossing, what would it feel like? It would be a place where direction doesn't mean what it does here. Up and down, forward and back might swirl together. The gravity would be so strong, the curvature of space so extreme, that light itself would dance in spirals around you. Imagine shadows with no source, horizons that bend in on themselves, a sense of falling forever, but never hitting the bottom. A dream of being folded into the fabric of the universe, stitched into the dark like a star nobody can see. It's a haunting idea, but it's also beautiful. The black hole isn't just a monster, it's a question mark, a reminder that even the universe has places where it says, I don't know yet, places we might one day understand, or maybe never fully grasp. And in that unknowing, there's space for wonder to grow. So the next time you see a black hole on the cover of a book, or spinning in a movie, or hidden in the heart of a galaxy, remember that crossing it is something no human has ever done. Yet our minds cross it all the time. We drift toward its darkness in our thoughts, and sometimes in that drifting, we find a quiet sense of awe, not because we'd survive, but because we love to wonder if we could. Let that curiosity stay with you as we keep exploring this cosmic puzzle, piece by piece, idea by idea. There is so much more to see. There's something quietly magical about the edge of a black hole. It's not just that it's a place where light disappears, or that gravity pulls so fiercely. It's that time itself begins to bend in ways that our ordinary days could never show us. If you've ever wished you could peek into the future, stand in the present, and watch centuries pass like clouds drifting by, the event horizon of a black hole is where that wish becomes a strange, impossible kind of truth. Let's imagine you again, drifting near that invisible boundary. You're protected, wrapped in a soft, impossible suit that keeps you from the heat and the radiation and the spaghettifying stretch. Just you, floating at the edge. To you, everything feels normal. Your watch ticks on, your heart keeps its rhythm. Your thoughts wander like they always do. But to anyone watching you from far away, maybe an astronaut friend on a safe spaceship orbiting nearby, you would begin to look different. Slower, softer, frozen. This is time dilation, a beautiful mind bending part of Einstein's general theory of relativity. The closer you drift toward the event horizon, the stronger the black hole's gravity tugs at you. And as it does, it bends space, but also bends time. To you, a second is still a second. A minute still slips by like a sigh. But to the rest of the universe, those seconds stretch and stretch until they become hours, days, centuries. If your friend watched through a telescope, they'd see you hovering there at the edge, moving more and more slowly as you approach the event horizon. They could wave, but you wouldn't wave back in any way they could see. Your wave would seem to pause mid-air. The light from your body would struggle to climb out of that deep gravitational well. It would be redshifted, the colors sliding down the spectrum until you faded from view altogether, not because you were gone, but because your image was stuck in time's slow spiral. In this way, you'd become an echo at the edge. From the outside, you'd appear to never cross the line. You'd linger there, a ghostly silhouette, while the entire universe carried on. Stars would live and die, galaxies would drift apart, civilizations might rise and fall, and still, there you'd be, caught forever in that moment, a single blink drawn out across the age of the cosmos. And yet, inside your suit, you wouldn't notice. You'd feel the seconds pass normally. You'd see the universe behind you shift. Light would bend. The clock you brought with you would tick on faithfully. You might even see the distant galaxies change, a movie of cosmic evolution playing out in the sky, while your own heartbeat stays calm and steady. It makes you wonder what time travel really means, because here at the lip of a black hole, you're not stepping into a machine with whirring gears. You're not vanishing into a bright tunnel. You're just sitting in a place where time stretches and twists like taffy, showing you the future, not by speeding you up, but by slowing you down. Your life becomes a quiet window, your body a reminder that time is not always what we feel it to be. Some scientists imagine that this is what makes black holes feel so haunting. They are not just places that swallow matter and light, they are places that trap time itself. Stories and memories drift inward, clocks stop making sense, moments get pinned to the fabric of space, like stars stitched into a cosmic quilt. And yet, even with all we know, this remains one of the gentlest mysteries of them all. A black hole doesn't just pull you in, it pulls your future out in front of you. It spreads it across the universe's canvas, letting you watch from your tiny vantage point while the rest of the cosmos hurries past. So, if you were to drift there tonight, to the edge of that horizon, what would you see? Would you see Earth turning silently below you? The sun growing old in fast motion, flickering into a red giant, fading into a white dwarf? Would you see the stars changing places, constellations unraveling like threads in a worn blanket? Would you glimpse the faint glow of the last light the universe has to give? It's beautiful to imagine, and maybe a little sad too, because you'd be there, caught between the pull inward and the world you left behind. A reminder that our universe holds secrets, not just in its distant places, but in the very way it lets moments slip away. The next time you hear about black holes bending time, maybe you'll remember this, that at their edge, time is not an arrow, it's a pool, a whirl, a gentle spiral where you could float forever, watching tomorrow arrive, one stretched out second at a time. And as we drift on in this story, keep that idea tucked close, that the universe still holds places where time itself becomes soft, and in those places, our wonder can travel farther than any spaceship ever will. If you've stayed with me this far, drifting through the deep folds of space, you know by now that black holes are more than just hungry monsters in the dark. They are strange gates where light, time, and matter tangle in ways our minds can barely touch. But tonight, let's let that curiosity wander one step further. Let's imagine not just what black holes do to the fabric of the universe, but what they might mean to someone else out there. Someone not human, someone clever, patient, so far ahead of us that our wildest sci fi dreams might feel like bedtime stories to them. Some scientists and many dreamers wonder about this. If there are civilizations scattered among the stars, millions of years older than us, maybe billions, would they ignore black holes? Or would they find a way to use them, turning these cosmic beasts into the greatest engines ever built? It sounds like something out of a movie, but let's play with the idea together. Black holes are fountains of energy if you know how to sip from them without falling in. Around some black holes, especially spinning ones, there is a swirling disk of superheated gas and dust. This accretion disk can blaze brighter than an entire galaxy. And right at the edges, physics creates a cosmic trick, a region called the ergosphere, where space itself drags around the black hole's spin. In this swirl, there's a theoretical way to steal a bit of that energy. The Penrose process. Scientists call it a puzzle piece first imagined by Roger Penrose, who looked at the spinning shadow of a black hole and wondered, what if you could dip in just enough to grab energy and escape again? Now picture a civilization so advanced that building ships or stations at the edge of that ergosphere is no harder for them than us building wind turbines by the sea. They could drop material in, split it, catch some of it back, and siphon off huge amounts of power. Some physicists have calculated that black holes could be the ultimate power plants, far more efficient than the sun. This is where the whispers of Dyson spheres come in, those vast imaginary megastructures dreamed up by physicist Freeman Dyson in the 1960s. A Dyson sphere, in the original idea, is a shell or swarm of solar collectors built around a star to capture all its energy. But if you really wanted power, why stop at a star? Why not wrap a black hole? A Dyson sphere around a black hole, or more realistically, a Dyson swarm, a loose cloud of satellites and collectors, could gather energy from the blazing accretion disk, the Hawking radiation trickling away over time, and the jets that some black holes fire out for thousands of light years. If you could tame all that, you'd have a cosmic engine that never truly runs out, at least not for eons. In sci fi stories, people imagine civilizations clustering around these dark suns, living in habitats warmed by stolen energy, shielded from the cold vastness beyond. Maybe they tap into the gravitational lensing too, using the black hole's bendy gravity to send messages or spy across unfathomable distances. Maybe the oldest species live this way, drifting through time in rings of light around shadows that once devoured stars. And here we are, lying back, thinking about them. We've not seen a Dyson sphere, not even a fragment. We have no telescopic peek at a civilization wrapping itself around a black hole like a scarf in winter. But sometimes in astronomy, the silence is part of the mystery. We listen for strange shadows. We scan for dim stars that should be bright, but are hidden by something huge and artificial. Maybe one day a telescope will find a flicker that doesn't belong, a glimmer of alien industry holding back the pull of a black hole. Or maybe this is just a gentle story for tonight, a way to remind ourselves how small we are and how much bigger our imagination can be. If life can emerge around yellow suns like ours, why not around the most extreme objects in the universe? Why not think of beings who build homes where space time bends and light struggles to break free? One day, we might send our own probes to the edges of black holes. We might learn to capture some of that power. But for now, it is enough to lie here, warm and safe, and wonder if someone somewhere is already doing just that. Someone older than our Earth, someone patient enough to drift close to the edge without falling in, someone who looks at the universe's darkest secrets and sees not an ending, but a new beginning. Hold on to that thought. Let it drift around your mind like a little satellite in orbit. A reminder that in the quietest, strangest corners of the cosmos, there might be life that found a way to turn darkness into light. By now, you've floated beside tiny black holes that could fit inside a mountain and monsters that anchor entire galaxies. But among all these shadows in the dark, one stands out like a sleeping giant, whose sheer size stretches your imagination as wide as the sky itself. Its name is TON 618, A name that sounds like a catalog entry, but behind those letters and numbers is something almost too huge to hold in your mind. Astronomers first glimpsed Ton 618 in the 1950s, a little flicker of light hidden in the depths of a sky survey. Back then, it looked like just another quasar, one of those distant, dazzling beacons powered by supermassive black holes gobbling up matter faster than anything we see nearby. But decades later, with better telescopes and sharper eyes, they realized that this quasar's black hole is among the heaviest known in the universe. Ton 618 holds the mass of about 66 billion suns. Just pause for a heartbeat and let that number sink in. 66 billion, a black hole so huge that our own Milky Way's central giant, Sagittarius A, which already feels enormous to us, would be a pebble next to this mountain. It's the kind of number that feels unreal, but it's real enough that the light from Ton 618's feeding frenzy has been traveling toward us for billions of years, a lighthouse blinking from when the universe was young and crowded with baby galaxies. This means Ton 618 didn't get so massive overnight. It grew and grew while stars were still gathering into spirals, while our sun wasn't even a whisper yet. So, how does something like this come to be? How does a black hole grow so vast when the rules of physics seem to place gentle speed limits on how fast they can feed? Well, this is where the story stays fuzzy and full of questions, just the way sleepy mysteries should be. Some scientists think Ton 618 was born in a special patch of the early universe where gas and dust were thick and clumpy, feeding the newborn black hole like an endless feast. Imagine a cosmic nursery where instead of a single star collapsing to form a small black hole, entire clouds of primordial gas sink inward, skipping the middle steps, making a heavy seed right away. Then picture that seed anchoring a young galaxy, pulling matter inward for millions of years until it swells to billions of solar masses. Others wonder if these giants sometimes merge. If the universe is a dance floor of colliding galaxies, then maybe black holes like Ton 618 are the result of ancient unions, shadows swallowing shadows until only one remains, bigger than everything around it. And even with these ideas, we're still left with soft, unanswered puzzles. Ton 618 isn't alone. There are other titans scattered through space. Some may be bigger, hidden in the fog of cosmic distance, their light not yet reaching our curious eyes. Are they rare accidents, or does every galaxy, if given enough time and material, grow a monster at its core? There's something beautiful in knowing that we don't know. 10618 reminds us that our maps are still unfinished, our theories still full of gaps waiting to be colored in by new starlight. It's a gentle reminder that the universe is not just vast in distance, but vast in questions too. Now, bring your mind back from the edges of this enormous shadow and think about this. If you could stand at a safe distance and watch Ton 618 feed, you'd see a quasar so bright it could outshine trillions of stars all around it. You'd see jets of energy bursting out for millions of light years. You'd feel humbled by how something so invisible and silent up close can become one of the loudest things in the cosmos when it eats. It is humbling, isn't it, that all of this can be hidden inside a tiny speck in a photograph, a name scribbled in a catalog, a number that feels too big for our minds, but not too big for the universe to hold. Ton 618, the quiet giant, drifting so far away, yet showing us how small we still are in this cosmic wilderness. As you lie here tonight, think of that distant, massive shadow. Think of how it's been sitting there for billions of years, whispering light across space. It doesn't roar or boast, it just exists, calmly, patiently, a reminder that in a universe full of black holes, there's always one bigger than you'd expect. And maybe that's why we keep looking up, because every time we think we've found the biggest, the strangest, the final answer, the universe slips another secret into the darkness, waiting for the next curious mind to find it. And for now, that's enough. A single shadow out there, 66 billion times the weight of our sun, letting us wonder how big the unknown might really be. By now, you've wandered alongside the oldest, heaviest giants in the universe. You've drifted near ancient monsters like 2N618 that have been feeding for billions of years, growing fat on starlight and cosmic dust. But now, let's lean in close to a different corner of this dark story, a place where shadows are not colossal yet, a place where they're just beginning, like seeds tucked away in the soil of space, waiting to grow. These are baby black holes, the newborn shadows of the cosmos. It's a comforting thought, in a way, that even in the vast cold stretches of the universe, new things are always beginning. Some black holes are as old as galaxies themselves, but some may have been born just a moment ago, cosmically speaking, in the time it takes for you to drift off to sleep and dream of distant stars. So, how does a baby black hole come into being? Picture a star bigger than you can easily imagine, tens of times heavier than our sun, burning through its fuel like a roaring bonfire in the night. For millions of years it shines, blazing brighter than anything around it. But no fire burns forever. When that fuel is gone, the star's core collapses under its own weight, so heavy that the very fabric of space folds in on itself. If the remaining core is heavy enough, no force can push back, and a black hole is born. It's almost gentle when you think about it. A life lived, a light snuffed out, but instead of disappearing completely, the star leaves behind a quiet scar in the sky, something that holds memory in its mass, spinning softly in the dark. These newborn black holes are small by cosmic standards, just a few times the mass of our sun, but they're still heavy enough to pull in anything that comes too close. They drift through the galaxy like tiny cosmic seeds. Some wander alone through interstellar space, hidden waiting. Others stay close to where they were born, near the remnants of their parent stars, wrapped in clouds of gas and dust. Sometimes, if you have the right eyes, you can spot one of these baby black holes by the way it eats. It might pull gas from a nearby star, creating a swirling disk of hot material that lights up X rays, like a cosmic scream that says, "Here I am, I'm growing." Astronomers listen for these whispers, or rather, these roars, using space telescopes that see the universe in wavelengths our eyes never could. But are new black holes still being born today? Almost certainly. Massive stars are still living and dying all across the universe. Somewhere right now, in a galaxy far away, a star may be taking its final breath, its core collapsing inward, its light dimming for the last time. And in that quiet moment, a newborn black hole comes into being, a fresh shadow added to the millions, perhaps billions, already drifting out there. There are other ways they might form too. Some scientists wonder if the collisions of neutron stars, the ultra dense cores left behind by smaller supernovae, could squeeze so much matter into such a tiny space that a black hole forms instantly. It's like watching two puzzle pieces crash together to create a hole in the very fabric of the universe. The gravitational waves from these collisions ripple through space time, and if we're lucky, we can catch them with special detectors here on Earth. It's like listening to the heartbeat of the cosmos as it gives birth to something new and invisible. And then there's the mystery of primordial black holes, the idea that some tiny black holes might have formed right after the Big Bang, when the universe was hot and chaotic and everything was crowding into everything else. These would be the oldest babies imaginable, shadows that have been drifting quietly since the dawn of time. No one has seen a primordial black hole for certain yet, but if they exist, they'd be like seeds scattered through space, some tiny enough to be no bigger than a mountain, yet heavier than 1,000 Earths. Some scientists think they could even be part of what we call dark matter, that invisible substance that holds galaxies together. Imagine that, the universe held together by ancient baby shadows. Whether they're born in a brilliant supernova, squeezed from colliding stars, or left over from the very beginning, baby black holes remind us that the universe is always recycling, always renewing itself. Nothing really disappears, it just changes shape, shifts form, whispers into a different kind of existence. So tonight, as you lie here listening, think about those quiet births happening in distant corners of the cosmos. Somewhere, a star's light fades and a new black hole stirs awake. Somewhere, a pair of neutron stars spiral into each other and vanish into a single newborn darkness. And somewhere, maybe, a tiny primordial black hole drifts by, unnoticed, carrying secrets from a time when the universe was only seconds old. The next time you look up at the stars, know that for every one you see shining, there may be a baby black hole out there, invisible and silent, waiting in the dark. Each one a tiny reminder that the universe never really stops creating. It just keeps breathing in and out, birthing shadows as gently as it births light. Sometimes when you look up at the night sky, you feel like you're seeing everything there is to see. Stars scattered like spilled sugar across dark velvet, the gentle swish of the Milky Way, the quiet promise that the universe is spread out before you, open and visible. But that's only half true, because in all that starlight, there are shadows that move, travelers that slip through the galaxy, unseen by our eyes, unlit by any nearby sun. These are the hidden black holes, the rogue wanderers, the ones we miss. Most black holes are born from dying stars, and many stay where they were formed, quietly spinning in the center of a cloud of gas, or orbiting another star like a secret twin. Some feast on their neighbors, pulling in gas and dust that lights up in X rays and gives them away. But not all black holes are so tied down. Some are flung out into the galaxy like marbles on an endless floor, drifting far from where they began. Imagine a black hole set loose, a chunk of collapsed star so heavy that it warps the fabric of space around it. Nothing shines from it, nothing reflects off it. It just glides through the darkness like a ghost ship in an ocean without light. No sails, no lamps, no glow to warn you it's coming. If you were drifting nearby, you wouldn't see it with your eyes. You'd only feel its pull, a soft tug at first, then stronger until it owned you completely. How does a black hole go rogue? Sometimes, when a star explodes in a supernova, the blast is uneven. The core collapses inward, becoming a black hole, but the explosion pushes it hard enough to send it speeding away. Or two stars locked in a tight embrace might dance too close, and one might collapse, the other kicked away, while the new black hole drifts free, no longer anchored to its birthplace. The Milky Way, our galactic home, is old and wide and full of these hidden travelers. Scientists think there could be millions of them, millions of black holes drifting quietly between the stars, each one an invisible bruise in the fabric of space. Some are big and ancient, others tiny and primordial, leftovers from the chaos right after the Big Bang. They don't give off light. They don't have a disk of gas to show us where they are. They don't call attention to themselves at all. So, how do we know they're there? We listen for them. We look for stars that suddenly drift in odd ways, wobbling in their paths as if tugged by a ghostly hand. We scan the sky for tiny distortions, patches where distant starlight bends, and curves for no obvious reason. That bending, gravitational lensing, is like a clue, a fingerprint pressed gently into the fabric of space. It says something heavy is passing through, something silent and dark. And sometimes we do spot one in the act of traveling. Just recently, astronomers found a rogue black hole wandering through our galaxy, not by seeing it directly, but by watching the way its invisible mass bent the light of a background star. For months, they tracked that gentle lensing, proof that a traveler was there, moving across the cosmic sea with no companion, no light, no fanfare, just drifting. It makes you wonder, doesn't it? How many are out there? How many shadows glide through the same neighborhoods as our sun, so close that on a cosmic scale they're almost next door? Maybe one passes through a quiet part of the galaxy right now, unseen but pulling at the clouds of gas, stirring them just enough that one day a new star might be born from the disturbance. Even in its silence, a black hole can shape creation. Some dreamers like to imagine what would happen if a rogue black hole came near our solar system. Would we see the effects in time? Would the planets wobble? Would the sun feel its pull? The truth is, it would probably announce itself only when it was too close to ignore. Earth's orbit might shift ever so slightly. The outer planets might drift. Comets in the Oort cloud could be nudged inward, raining down on us in a sparkling show of icy debris. But even then, the chance of that happening is so tiny, it's almost funny. Space is wide beyond our dreams, and even millions of travelers, spread through billions of light years, means that each one is still separated by oceans of emptiness. Like ships crossing different seas, they rarely meet. Still, the idea that they're out there, silent voyagers on paths no one can trace, adds a soft shiver to the wonder of the night. So the next time you lie under the stars, remember this: not every shadow can be seen. Some move without a whisper, drifting through the arms of the galaxy like a secret. They don't want your attention, they just want to wander. And in that wandering, they remind us how much of the universe is still hidden. Not gone, just waiting for eyes patient enough to find them. What if I asked you to imagine something so small you could hold it in your palm, yet so heavy it could pull the whole world toward it, bit by bit, without ever making a sound? Tonight, let's drift into one of those sleepy what ifs that floats somewhere between dream and physics. What if our Earth had its own tiny black hole right at its center? A black hole no bigger than a marble, tucked deep beneath our feet, wrapped inside the spinning layers of rock and molten iron. Would we even know? Let's start with the idea itself. A black hole doesn't have to be massive. In theory, one could be as small as a grain of sand if it were dense enough. Imagine the weight of an entire mountain pressed down into something so tiny you could balance it on your fingertip. Now, push that idea further. Squeeze all that mass down even more until gravity becomes so intense that space folds inward and nothing, not even light, can slip away. That's our tiny black hole, small in size, infinite in pull. If such a thing existed at Earth's core, it wouldn't glow, it wouldn't hum, it wouldn't announce itself with any grand display. It would simply sit there, patient, as the Earth spun around it, layer upon layer of rock and iron wrapped like a cloak around an invisible monarch. You might wonder, wouldn't it gobble us up instantly, swallow the whole planet in a single cosmic bite? That's the image we often get from movies: black holes as unstoppable monsters, tearing through everything in their path. But reality is softer, stranger. A black hole, even one hiding in our planet's heart, can only eat what comes close enough. It would start by pulling in the iron and nickel that make up Earth's inner core, feeding slowly, atom by atom. But here's the twist. If it were really marble sized, about the mass of a small asteroid, it would take a very long time to grow. Eons might pass before it made any noticeable dent in the layers above. Deep underground, we wouldn't feel much at first. No sudden holes opening under our feet. No earthquakes that didn't already have other causes. The black hole's tiny horizon would stay hidden, buried under thousands of kilometers of rock. The surface would stay green and blue. The oceans would keep their tides. The winds would still blow across mountains and plains, oblivious to the quiet hunger miles below. Could we detect it? Maybe. If we looked carefully, the Earth's gravity might feel just a bit stronger than expected. Satellites might notice tiny shifts in their orbits, not enough to scare us, but enough for a curious scientist to scratch their head and wonder why the numbers don't quite add up. Seismic waves, the echoes of earthquakes, might show tiny distortions as they pass through the planet's core, bending around the dense pocket like light curves around a hidden lens. And if we did find it, if we somehow discovered that deep below our feet, a tiny black hole was slowly sipping at our world's heart, what would we do? There's no way to pull it out. You can't shovel a black hole into a bucket and launch it into space. Its gravity keeps it pinned in place. But maybe knowing would change how we see the ground we stand on. Every step above a secret, so deep, so silent, so powerful, yet so patient that it lets life flourish for millions of years without fuss. There are people who imagine that tiny black holes might be all around us already, not hiding in Earth's core, but drifting through space like invisible grains of cosmic dust. Some theories about the early universe suggest that right after the Big Bang, when everything was hot and crowded and chaotic, tiny black holes might have formed like bubbles in boiling soup. Some of those might have survived, wandering through space ever since. Most would pass by without ever coming close. But what if one slipped inside a planet? Would it sit still, or would it drift through like a ghost, leaving only the faintest trail behind? In this what if story, the Earth keeps spinning, oceans keep waving hello to the moon, clouds keep drifting over cities and forests and deserts. We keep building homes, writing books, planting gardens, all while a tiny black hole curls up in the deep, an ancient seat of gravity older than any fossil, a reminder that the universe loves to keep secrets right under our feet. So next time you stand barefoot on the grass or feel the ground solid beneath you, pause for a moment. Think of all the hidden layers, all the molten currents flowing slowly around the core, all the mysteries that might nestle deeper still. Maybe there's nothing there. Maybe it's just rock and iron spinning faithfully as it always has. But maybe, just maybe, there's a tiny black hole, a sleeping marble of the cosmos, holding a story we haven't finished reading yet. Isn't it soft and strange to know that sometimes the biggest mysteries might be buried right where we stand? Let's drift on, wondering gently about the secrets we haven't yet found. When you stand beneath the night sky, there's something deeply comforting about the stars. They're far away, yet they keep us company. They remind us that the universe is ancient and huge, but also that we belong to it, tiny and curious and full of questions. And maybe the greatest thing about black holes is how they gather our questions in the dark, like secret seeds, waiting to grow into answers we haven't found yet. So tonight, let's wander softly through a few of these unanswered puzzles, not to solve them, but just to sit with them, like you'd sit by a campfire with old friends, swapping stories you know will never be finished. First, the event horizon, that invisible boundary that wraps itself around a black hole like a silent cloak. It's the ultimate point of no return. across it, and there's no turning back. No spaceship, no beam of light, no message in a bottle can ever come back across. The event horizon is both an edge and a veil. It hides what happens inside from the rest of the universe, and in doing so, it invites endless curiosity. Scientists have worked out equations that describe this border beautifully, but what truly lies just beyond it, the instant you pass through, remains hidden behind that cosmic curtain. Then there's the singularity, the mysterious heart of every black hole. The math says that all the mass inside collapses down into a point with infinite density, a place where our normal rules of physics break down and the numbers start whispering nonsense. It's a place so extreme that time and space themselves fold in on each other. But is it really a point? Some theories, like fuzzballs or quantum loops, say maybe it's not a sharp dot at all, but something more tangled and gentle, a swirl of strings or particles that we just don't understand yet. For now, the singularity sits there in our minds, not as an answer, but as a shimmering question mark. And then there's the information paradox, maybe the trickiest riddle of all. If you drop something into a black hole, a star, a spaceship, a library of books, what happens to the information that describes that thing? Physics says information can't be destroyed. The universe likes to keep its secrets filed away somewhere, even if they're scrambled beyond recognition. But black holes, with their one way horizons, seem to gulp down all that detail and never give it back. Stephen Hawking made this puzzle famous when he showed that black holes can slowly evaporate through tiny leaks of radiation. So, if the black hole vanishes over time, where does the information go? Does it get smeared on the horizon? Is it released in a final whisper as the hole dies? Or does the universe quietly break its own rules? We don't know yet, but we're listening. These three, the horizon, the singularity, the paradox, are just the biggest lights in a whole constellation of questions. What happens if two black holes merge? How do we know they're really the same as our theories say? What's the connection between the smallest particles and the biggest gravitational monsters? Can we find a theory of quantum gravity that holds all these truths together like threads in a single fabric? Sometimes, when you watch scientists talk about these mysteries, they light up like children. They use big words, equations that swirl across chalkboards, ideas so new they don't have proper names yet. But beneath it all is a simple wonder. We don't know yet. That yet is what keeps us looking up. It's what keeps telescopes pointed at the heart of galaxies. It's what sends satellites drifting to the edge of our solar system. It's what keeps curious minds awake at 3 in the morning, reading old papers by Einstein and new ones by students who might one day crack the code. And black holes remind us that it's okay not to know everything. In fact, it's beautiful. It means there's always more room to grow, to imagine, to dream. Our ancestors looked up at the stars and didn't even know what gravity was. Now, we talk about bending space and time, about dark matter and quantum fuzz. One day, maybe someone will stand under this same sky and say, we know what happens past the horizon. We know what the singularity is made of. We know where the information goes. But tonight, we just rest in the unknowing. So if your mind starts to wander back to these questions when you look up at the night sky, that's good. Let them drift like fireflies in the dark. Let them remind you that the universe is more than facts and formulas. It's a story still being written, and you, lying there with your eyes half closed, are part of it. You're one of its softest mysteries, wandering in the dark, helping keep the questions alive. And maybe that's the most beautiful thing, not the answers we find, but the puzzles we choose to love. Sometimes, in the middle of an ordinary day, you might pause and remember There's a black hole out there right now drifting through space. Silent, invisible, massive beyond imagining. It could be swallowing stars, bending light into rings, pulling time tight like thread between your fingers. And somehow, instead of being only terrifying, that thought can feel like an invitation to dream deeper. Black holes have always been painted as monsters in stories, hungry cosmic beasts that devour everything they touch. But when you look closer, they're not just destroyers, they're mirrors reflecting our questions back at us. They remind us how much we still don't know and how big our curiosity can be. Think of it like this: a black hole is born from something that lived a whole life first. A giant star burning bright for millions or billions of years, making light that may have guided ancient sailors or lit up planets we'll never see. Then, one day, it collapses under its own weight. Gravity wins. The star's shining layers fall inward, tighter and tighter, until they make something so dense, so heavy, that it swallows its own light. But what remains is not just an ending, it's a doorway in the fabric of the universe that challenges our minds to keep peering through. And maybe that's what feels so powerful about them. Black holes are a cosmic way of saying there's more, more than we can touch, more than we can see, more than we can know, for now. They hold secrets like an old library keeps forgotten books. They bend the rules we thought were unbreakable. They're puzzles so complicated that entire generations of scientists have given their lives to untangling just a few threads. They also remind us of our smallness, but in a gentle way. You could be lying in a field on a summer night, staring up, and somewhere up there is a supermassive black hole with the mass of billions of suns spinning patiently at the heart of a galaxy. And yet, here you are, with your own heartbeat, your breath going in and out, your mind alive with wonder. The universe is vast, but it is also personal. It lets you exist alongside these colossal mysteries. It lets you ask your questions in the dark. And when we discover more about black holes, we're really discovering more about ourselves. Each new photograph, like that first blurry ring of the Event Horizon telescope, feels like peeking into our own future. It says, look what we can do when we wonder together. When we send probes and satellites and think up equations in tiny offices late at night. We're not just solving problems, we're building bridges to places our bodies may never reach. Black holes push us to imagine wormholes and white holes, parallel universes, and holographic realities. They expand our minds just by existing. They're also proof that the universe is never finished. A black hole can live for eons, growing and feeding, drifting and merging, and yet, thanks to Hawking's work, we know they can die too, slowly evaporating through faint whispers of radiation. It's as if the cosmos wants even its darkest corners to have a story arc: birth, life, death, and maybe even rebirth as their matter scatters and seeds new stars. There's a lesson in that. Endings are beginnings in disguise. And so they inspire awe because they make us humble. They remind us that the universe is not here to be tamed or put in a box. It's here to astonish us. It's here to give us stories we can pass down, ideas that children can dream about when they're lying on their backs, tracing constellations with sleepy fingers. It's here to make us feel small, but in that smallness, to feel connected to something endlessly bigger. When you think of black holes now, maybe you'll remember they're not only cosmic traps or fearful devourers, they're giant cosmic mirrors. When you look at them, you're really looking into your own curiosity, the part of you that asks why and keeps asking even when there's no easy answer. The part that understands that it's okay not to have everything figured out, because the mystery itself is what keeps us reaching for the stars. So tonight, When you drift off, know that out there in the quiet dark, black holes are spinning, waiting, weaving the edges of reality into something we can't quite see yet. And maybe, just maybe, they're whispering back to us. Keep wondering, keep looking up. There's so much more to find. Somewhere out there in the deep fabric of space, a black hole spins in silence. No eyes can see past its event horizon. No light can escape its pull. And yet, when you sit with the thought for a while, it doesn't feel like a threat. It feels like a quiet promise, a soft invitation to believe that the universe is not finished telling its story. Maybe that's the real secret. Maybe what hides beyond a black hole isn't an ending at all, not an empty void that swallows everything for good, but a door, a passage, a cosmic threshold just waiting for our curiosity to knock. It could be that every black hole, every shadowed edge, every bend in space time is really just the universe reminding us how much more there is to discover. Think about how it feels to stand at the edge of an ocean at night. You hear the waves, but you can't see their full reach. You know that somewhere beyond the black water are islands and creatures you'll never meet, tides moving in rhythms older than memory. And yet that darkness doesn't push you away. It pulls you closer. It makes you dream bigger. Black holes are like that. They are our cosmic oceans, dark but not empty, hidden but not lost, unfathomable but somehow deeply welcoming to a mind that loves to wonder. There is a special magic in not knowing everything. For all our equations and telescopes, for all the scientists who have stayed up through long nights scribbling out possibilities on scraps of paper, for all the images beamed back from deep space probes, black holes still hold secrets. And maybe that's a good thing. Mystery is part of what makes the world feel alive. It gives our curiosity somewhere to run, a horizon line to chase, even when we know we'll never quite catch it. Inside every black hole is a riddle that even the laws of physics whisper about with caution. At its heart is the singularity, a place where our math breaks down, where time and space fold in ways we can't yet describe. Around it is the event horizon, a soft edge that says this far, no further, to anything that tries to look inside. And yet here we are, staring anyway, not because we think we'll solve it tonight, but because the act of looking makes us more ourselves. It makes us explorers in the deepest sense. Maybe the most beautiful thought is that we are connected to these distant giants. Their gravity shapes the galaxies we live in. Their births and deaths send ripples through space-time that we can now hear with our detectors. When a black hole forms somewhere far away, it is an echo of an old star's final breath. When it evaporates, eons from now, its whispers of radiation will drift back into the universe, feeding new possibilities we can't yet name. So even when they feel so far, so untouchable, they're woven into our story too. When you close your eyes tonight, imagine for a moment that you're drifting near the edge of one. Imagine the stars behind you stretched into a perfect ring of light, all of time curling into a strange, slow swirl. On this side, you are small, a fragile human asking big questions under a quilt or a favorite blanket. On the other side, who knows? Maybe a newborn universe, blooming like a hidden garden. Maybe a bridge to somewhere else. Maybe just more questions, the most beautiful kind. What if all the secrets of black holes are not there to taunt us, but to keep us dreaming? To remind us that we don't have to have every answer, that there is wonder in leaving space for the unknown. It could be that every black hole is really a cosmic promise, that for every piece of the universe we do understand, there are 1,000 more waiting to be uncovered by minds not yet born. So rest in that tonight. Let the unsolved puzzles feel gentle, not frightening. Let them remind you that your mind is wired to roam, to peek into the dark, to stand on the shore of mystery, and feel the pull to wade in further. You don't have to cross the event horizon to feel what's on the other side. All you need is your wonder, wide and quiet as the night sky, and the comfort of knowing that what lies beyond may never be just an end. It may be a door, just waiting for you to keep asking, keep searching, keep dreaming. So here we are, you and I, right at the quiet edge of this long, dreamy journey through the deepest shadows of the universe. You've wandered so far tonight. From the moment you lay back, eyes open or closed, blanket tucked around your shoulders, you've traveled farther than light itself could ever go in a single breath, and you did it without leaving your bed or your favorite chair. That's the beautiful thing about the mind, how it drifts beyond every wall and roof and atmosphere to brush against the edges of the unknowable. Tonight, you and I sat together with black holes. We peeked into places where light disappears, where time drips like honey, where the fabric of the cosmos folds in on itself like a note tucked into a pocket. We wondered what might lie beyond those dark gates, new universes, or perhaps just more mysteries waiting patiently for us to grow curious enough, brave enough to seek them out. And maybe you felt something loosen inside you as we drifted through these questions, a sense that you don't have to know everything to feel safe here, that it's all right not to have every puzzle solved. Maybe the secrets inside black holes are reminders that sometimes the questions are enough, that they nourish your mind, like water on roots you didn't know were thirsty. Out there, hidden in the folds of distant galaxies, are these gentle monsters spinning, swallowing, shaping the dance of stars around them. They hold the centers of galaxies steady, their gravity so strong it anchors the swirl of billions of suns. They are quiet, invisible anchors in a universe that is always moving, always humming with secrets. And you, small but not insignificant, get to be part of this story. You are stardust with a mind that can imagine what lies behind the veil. You are a heartbeat that dares to stand on the edge of cosmic silence and ask, what if? So, here at the end, I just want to say thank you. Thank you for letting your thoughts drift with me tonight. Thank you for bringing your gentle curiosity to the darkness. I hope this little bedtime adventure gave your mind a soft place to rest, even as it filled up with wonder. Maybe you feel your eyes growing heavy now, the weight of sleep pressing gently behind them, like the tug of a tide pulling you back to shore. And if sleep hasn't come yet, that's okay too. Maybe you'll stay up a bit longer, lying there in the hush of your room, replaying those distant shadows, seeing the black hole's soft halo of light in your mind. Maybe you'll wonder how many more secrets the universe holds, tucked into folds of dark matter, hidden behind cosmic curtains we haven't drawn back yet. If that curiosity keeps you awake for a little while, let it let it swirl around you like stardust. You can always drift off when you're ready. Wonder makes for the sweetest dreams. If this journey made you smile, or sigh, or just breathe a little deeper tonight, I'd be so grateful if you gently tapped that like button. Maybe even subscribe if you'd like to drift through more sleepy mysteries with me again soon. And if you're listening from somewhere special, a city skyline glowing through your window, a quiet cabin in the woods, or a tiny corner of the world only you call home, let me know in the comments. I love seeing the sleepy map light up with stargazers like you, tucked all across this spinning planet. Wherever you are, I hope you feel held. I hope you feel tiny in the best possible way, the kind of tiny that makes the universe feel big enough to hold every one of your dreams, big enough to keep its secrets safe until we are ready to find them, and patient enough to whisper them to us, one by one, on nights just like this. So now, stargazer, it's time to close your eyes, if you haven't yet, to let your mind curl up like a soft cat in a warm patch of sunlight. To remember that out there, past the roofs and clouds and atmosphere, a million black holes are spinning quietly, holding the shape of the cosmos together while you sleep. They don't need your light. You keep that safe inside you. They don't need your answers. You keep your questions close, like smooth stones in your pocket. All they do is remind you that the universe is vast and gentle enough to carry you through the night. So sleep well, stargazer. Sleep well, and let your dreams drift out into the darkness, fearless and free. The universe holds you gently, now and always. And when you wake, may you carry a little piece of this wonder with you, a reminder that what lies beyond is not just darkness, but a door waiting to be opened again and again. Good night,